Please, Dr. Arifin, for your opening remarks.
Bismillahirrahmanirrahim. In the name of Allah, the Merciful, the Compassionate. Assalamualaikum warahmatullahi wabarakatuh. May peace and blessing be with you. Dear engineers, students, participants, ladies and gentlemen, we have to congratulate the committee of this international web seminar on the Nano High Throughput Satellite Technologies, Challenges and Prospects, for their hard work allowing the running of this online gathering. At the outset, this event was a common initiative of the Indonesia GRS AES Joint Chapter of the IEEE and the Indonesia-ITU Concern Forum, or IICF, a non-profit organization which fosters the society to use the communications for their well-being. In the course of time, the SATCOM radar laboratory of Telkom University get into the loop. We are very proud that this initiative have received many support from both national and international institutions, such as Nanosat GPL, Trisakti University, University of Duisburg Essen, Bhakti.com Info, and Pacific Broadband Satellite. This web seminar is crafted to be the one which gives the introduction to the HTS subject, the way optimizing its trafficability, and its implementations in the smaller spacecraft. On the other hand, a panel discussion would be prepared to talk about how Indonesian internet users in such difficult areas could take benefit and be connected to the internet application, thanks to the high throughput satellite technology. We are all grateful that today we are going to learn from the authoritative expert in this very subject. Thanks to Indonesia sections of IEEE through its chair, Dr. Ing Wahyudi Hasbi, for kindly giving the keynote speech. Thanks to speakers, Mr. Filial Fahri from Electrical Department of Trisakti University, and Mr. Dwi Cahyono from University of Duisburg Essen. Thanks to the panelists, which is Bapak R. Sri Sanggrama Aradia. He is a satellite and access internet division head of Bhakti.com Info, and Mr. Christian Patuho, the CEO of Pacific Broadband Satellite. Thanks also to moderators, Mr. Edi Setiawan, Dr. Agnes Irwanti. Thanks to Mr. Satrio Darmanto for giving the closing remark. And finally, thanks to all members of the organizing committees, which is presided by Mr. Sandriones and Mr. Edward. In this opportunity, on behalf of the committee, we are to express our sincere gratitude to Pacific Broadband Satellite for the platinum sponsoring this event. Last but not least, our high appreciation should go to the audience for participating in this seminar, without whom this event becomes meaningless. Finally, we wish you all a full enjoyment of this workshop. Looking forward, by Allah permits, to have the opportunity to have an offline workshops in the future. Thank you very much and have a pleasant workshop. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Arifin, for your time. And before we continue, allow me to introduce our keynote speaker for today's seminar by reading his curriculum vitae. Dr. Arifin Wahyudi, born in Biak, Papua. And I would like to read the education history. Department of Physics, Hasanuddin University, Makassar, Indonesia in 2000. Master of Computer Science from Bogor Agricultural University, Bogor, Indonesia in 2011. Doctorate in Satellite Systems of Technische Universität Berlin, Germany work. Head of Satellite Technology Research Center, Aviation and Space Research Organization, National Research and Innovation Agency, or BRIN. Associate Research or Coordinator of Dissemination at the Center of Satellite Technology, National Aeronautics and Space Institute, or LAPAN, since 2017 until 2021. Chief Engineer of LAPAN A3 or IPB Satellite since 2013 until 2016, which has been in orbit since 2016. System Engineer for the development of LAPAN A2 or LAPAN Orari 2010 until 2013 and 2013 satellite orbiting in 2015. A member of main engineer team in development of LAPAN Subat satellite, the first of which was jointly developed in the Technische Universität Berlin in 2004 and launched in 2007. Awards. Recipient of the Stay Lancana Wirakarya Award from the President of the Republic of Indonesia, who was specifically awarded as an award for his services. Let me continue. For his services in designing and satellite development, in providing great service to the country and nation of Indonesia, so that it can be used as an example for others. Award from the head of LAPAN as Outstanding Employee in 2015, 10 years Satya Lancana from the President of the Republic of Indonesia. And for the membership and professional organization, the first one is Member of Council of Higher Education or DPT, Ministry of Education, Culture, Research, and Technology of Republic of Indonesia, 2021 until 2025. Chair of Institute of Electrical and Electronics Engineers or IEEE Indonesia in 2021 until 2022. Chairman of Directors International Amateur Radio Organization or IARU Region 3 2021-2024. IEEE Senior Member in Aerospace and Electronic System, Senior Member of American Institute of Aeronautics or IAAA, Chair of Professional Activity Division, IEEE Indonesia Section 2019-2020, Deputy Chairperson of the IEEE Indonesia Section since 2017-2019, Deputy Chair of Indonesia Section in Joint Chapter of IEEE Aerospace and Electronic System and IEEE Geoscience and Remote Sensing Society or IEEE AES or GRS since 2013, General Chair, IEEE International Conference on Aerospace and Remote Sensing, ICIRES 2014, 2015, 2018, and 2019. Member of Indonesia Amateur Radio Organization or ORARI with the call sign YC1PRY since 2010 and encourages amateur radio content on LAPAN A2 or ORARI satellite for backup communication. especially in event on a disaster in Indonesia. And a member of Indonesia Researcher Association or Himhanindo, Japan Geoscience Union, JPGU field. And for research, satellite system, microsatellite light, communication satellite, and satellite payloads. Active in satellite workshops and seminars held at several universities and institutions in Indonesia and also abroad, and has published more than 45 papers in journals and proceedings, conference, and also papers into international books. Such a great adventure and a lot of things that Dr. Wahyudi has achieved. And to Dr. Wahyudi, I would like to ask to enter the room for taking part for the keynote speakers.
Thank you, Mas Kinan. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning. Distinguished Dr. Arifin Nugroho, as a chair of IEEE Aerospace and Geoscience and Remote Sensing of Indonesia. Also, I can see here Mr. Edi Setiawan as a chair of IICF, and Mr. Satrio Darmanto and Dr. Agnes Irwanti from IEEE. And also I can see here a lot of friends here, Mr. Edward from Telkom University, and also the others that I cannot mention all the name. So first of all, thank you very much for the invitation for the very prestigious Nano High Throughput Satellite Technology webinars for today meeting. So I will, for the sake of the time, I will just start to share my screen first. So, okay, I hope you can see it now. Okay, so as a request from the organizer, I need to speak about the small satellite development in Indonesia. And then, first of all, before I continue with that, I would like to mention the new changes now in the country. So previously we can see that there are like 4 research institutions, like LAPAN here, National Institute of Aeronautics and Space, and LIPI or Indonesian Institute of Science, and BPPT, Agency for Assessment and Application Technology, and also BATAN. And plus, not only these 4 agencies, but including another 44 research and development units under other ministerial institutions, now become a BRIN, or National Research and Innovation Agency, based on Presidential Decree number 78 in 2021. If you can see here, so in Indonesia we have now is a huge organization as a called BRIN, and you can see here that under the president there are a steering board, chairman, and all the vice chairman and members. And here you can see there is a chairman of BRIN, and under the chairman of BRIN, there are several research organizations. As you can see here, there is a research organization for nuclear power, aeronautic and space, earth and maritime, biology and environment, agriculture and food, until like governance, economics, and public welfare. So you can see here that all the research institute that before separated under every ministerial is now joined together as one huge organization for research and innovation. And beside the research organization, under the chairman, there are principal inspector, executive summary, and there are several deputy that help the chairmen in terms of research and innovation management, let's say. And you can see here there are deputy for development policy, research and innovation policy, research and innovation infrastructure, facilitation, innovation, and regional research and innovation as well. So this deputy become the management for research and innovation, while the research organization will do all the research execution actually. And where are we now? For space and aeronautics, we are under research organization for aeronautica and space. So my center as a satellite technology research center, also under the research organization for aeronautica and space. This is explanation about the new organization now. So I hope that you all can see that now we have one single research and innovation agency with almost all the topic of research and innovation under this new organization. Okay, now we go back to our business now for about satellites. So as we know, there are several steps to go into the business, especially for the satellite. Of course, at the beginning, you have to get your business input and providing the platform and mission design. And at a later stage, you will have to get the subsystem acceptance and verification. And you start with the integration, having the environmental test campaign, launch support, the constellation operation, and data service delivery. And I just want to recall back that about the satellite types according to the mass. As we know that a large satellite typically will have like more than 1,000 kilograms, and the medium-sized satellite typically start from 500 until 1 ton kilogram, 1 ton, sorry. And then now we are here, right? So this is a small satellite. So there are at least 4 satellite type that starting from the mini satellite like 100 to 500 kilograms, micro satellite 10 to 100 kilograms, nano satellite 1 to 10 kilogram, and also pico satellite, which is less than 1 kilogram. So you can see here the huge of comparison between the huge satellite like this one, Cubesat. This has a 3.2 ton, and you can see the size here, and compare with very small or 2.5 kilogram satellite. So this is the disruption that's going to happen, or even already been happen now, and this is what we are gonna talking about. So if we see the current situation about the constellation application, especially for high throughput satellite system, we can see here at least there are 2 very important applications. Like for broadband internet application, there are 43 applications, and most of them also is coming to the IoT or Internet of Things and machine-to-machine application as well. So we can see here, beside optical satellite observation, also is one of the main topic currently. IoT and broadband internet also come into the picture here. Okay, and then, however, if we see the constellation, especially if we see the specific IoT and M2M, we can see here that still not many satellite is really been launched. There are a lot of plans, like we can see here, like K-LEO satellite, they announced about 300 satellite will be launched, but so far only 2. Lacuna Space, they plan to have like 240 launch satellite, but so far it's only 5. The Swarm is one of the quite doing well. They already launched like 121 instead 121 out of 150 for their planning. So another thing, of course, like Iridium Next is already been launched, all 75 satellite and so on. So we can see here a lot of plans is going on, but of course the execution or launch of the satellite system itself is still under development. So okay, and then this is also another data that we can see that for broadband internet, how about the broadband internet? Or we can say one of the topic here that high throughput satellite. So some example, there is Astra planning to launch like 13,620 satellites so far, but we can see here nothing has been launched. Guowang, I believe from China, also planning like 12,900 satellite. So far, still waiting for launch. We can see here SpaceX, of course, they have been launched 1,740 satellite already out of their planning about 41,000. So you can imagine how big it is, this constellation, right? And Amazon, the Project Cooper, as they have planned about 3,000, but so far still waiting for launch, I believe. And there is some other planning like from Hanwha, Galaxy Space, and OneWeb already starting. Now we can see that even though they get bankrupt somehow, but now they are in business again. So they launched already about 254 satellites. So the launch is ongoing. So we can see there are a lot of plans here as well in broadband internet constellation. And now we can try to see from the size of the satellite that they have been launched. So if we can go here in the table, we can see that actually the satellite itself is not so small. Yeah. So for example, the SpaceX, the Starlink, the weight of the satellite is like 200 kilogram classes here. And OneWeb, they try to make it in 150 kilograms. So, and the Telesat, let's say, they have like 800 kilogram class. So if we can see here, so the high throughput satellite or let's say broadband internet constellation so far in LEO still play in a minimum like 150 kilogram class, right? So this is the mass that so far has been launched and has been proved. Okay, and then okay, now how about us in Indonesia? So far, BRIN has a program we call in research we call it a LEO constellation satellite for narrow band communication. So the idea was we want to launch like 10 satellite in equatorial orbit here, and the mission is to supporting early disaster warning, and then for maritime surveillance and machine-to-machine, and all, including the IoT narrow communication. So we can see here some simulation for the application. So the satellite will be launched in equatorial orbit, which is of course is very rare orbit, and but anyway we have the experience how to launch the satellite into the equatorial orbit so far. So based on the experience, we can we know what to do with this kind of orbit. So that's the reason why we also plan to have this machine-to-machine and IoT communication plan in this orbit. And then I also would like to inform that so far our center as a satellite research center, we already gained like 25-year satellite services in orbit based on the 3 satellites has been launched from 8 Cubesat satellite for 8E1 and 8E2 for amateur communication and also image or remote sensing. And also 8E3 here also used as a remote sensing satellite. And also we are measuring the Earth magnetic field. And then 8E4 will be launched at least next year. So this year we will finish the AIT for 8E4 satellite. So it will be ready to be launched by end of this year. And we just have a discussion with the Indian Space Research Organization about the planning to launch the satellite very soon, latest like next year. And then this is one more, we call it 8E4 as I mentioned. This is satellite for narrow data communication. So from this point, we can gain not only remote sensing satellite system, but also including data communication. And then we have quite a lot of facility to doing all this satellite research. As you can see here, we have all the thermal vacuum chamber for environment tests for the satellite components or even the satellite. So our thermal vacuum chamber here can fit with 1 by 1 meter satellite system. So we can test a full satellite in this environment test here. And then we have the vibration test, which is very important, especially for if we want to go to launch the satellite. So we have to characterize our satellite system into the vibration test so that it can be accepted for launch with several rocket types. And then we also have the anechoic chamber, of course, to test the RF and EMC test. And this is one of the biggest anechoic chamber in Indonesia, and then it has quite wide range frequency from 1 megahertz up to 40 gigahertz. So if you like to make any tests for RF and EMC, please come and join us. And the EMC, we also apply military standard for mil spec. So all the tests for space system and military system can be tested here. So another thing, of course, we have the satellite mission control center to control our satellite. Of course, we need the ground station as well, and we have several ground stations. And even the current planning, we plan also to have more ground station all over Indonesia. And then this is maybe the new things that I would like to show to you. So this is the current plan. Maybe you have heard in newspaper or read in newspaper that currently BRIN has ideas to launch like 19 satellites. So here we are. So if you can see here, there are several types of satellite. First, high resolution satellite. And then this is VHR, is a very high resolution satellite, like 30 resolutions. And then there are communication satellite. So this is maybe similar with our topic today. So this at least 10 data communication satellite that we plan to have. And then one more important thing, once we have a constellation, it might be helpful or even needed to have the data relay system or a geosatellite, but for data relay for all the constellation that we have. Okay, and then this is the simulation. So we can see here, this is the communication satellite under Leo constellation. And then this is 6 satellites for remote sensing, 2 for very high resolution and 4 for high resolution. And then you can see here there is some inclined orbit. So this was the SAR, or synthetic aperture radar. And then you can see here the TRSS is coming. So this is the whole orbital plane characteristic that we plan to have. And then if we can describe here, so 4 high resolutions, 2 very high, and including 1 communication geo for data relay system. So what is the things to be prepared? Of course, the current organization under BRIN, we are always now talking about the business model. So the research that we are doing has to be in line with the business model. So we don't want to grow ourselves. We want to grow the whole ecosystem, not only the government, but of course, the players from the private company or state-owned company. So currently, we try to develop the business model like the joint development or through public-private partnerships. And most of it should be Indonesian players. Of course, we can have some collaboration or a joint development with our partner from other countries. So this is still open, but of course, the main idea is how can we make the business model for the satellite constellation, and most of it must be developed in Indonesia as well. So that's the reason why we prepare all the facility infrastructure so that the players from the private company or a state-owned company, they don't need to develop the very expensive infrastructure, but we will prepare for it, and then you can also just make the joint development with your partner, for example. And then another things that need things to be done or to be prepared is, of course, we have to prepare the human resources in the technology of, let's say, training of like TOT program, and also in satellite research. So this is very important. That's the reason why, as I mentioned, under BRIN, we have several schemes that invite ideas not only from our side as a research center, but also from the university, from a private company, even from startup. So under BRIN, we have several schemes also for startup. And I remember there are some startup already been joined in this funding scheme from BRIN. And another important thing that we have to prepare in our mind is the development of data processing, of course, the algorithm, the validation, the corrections. Since we are talking about high throughput satellite, of course, we need all of this. And then the very important one is about satellite frequency filing and coordination. So this is very important, as we know. So currently under BRIN itself, we are also have filing under this one. And from the government side, we need the policy support. So like easy investment, tax deduction, as you know, in Indonesia, we already have a tax deduction if you are doing a research, and you can get something like 300% tax deduction if it is really, if the company is really doing the research here. And another things like SBAS or satellite-based augmented system, this is also quite important. But the SBAS policy should come from the Ministry of Transportation. So this policy also will be needed. And of course, there are another support from other Indonesian ministry. And the last thing that also under BRIN ideas now is we are preparing and trying to think how we can develop the rocket and spaceport technology, because this is very important. If you don't have access to space, then it will be very difficult to launch your own satellite. So we have to go into this rocket and spaceport technology as well, so that you can not only develop the satellite, but of course we can launch from our area in Indonesia. I think I quite in time now, so this is I would like to mention to all of us. So I hope the slide or information will be helpful for the discussion later on. So thank you so much for your attention. I give it back to MC.
Thank you very much, Dr. Wahyudi, for your precious time and explanation. It's my pleasure to meet you today. So right now, it is the time for us to memorize the seminar by taking pictures together. I will count so we can get ready. For all the participants, please turn your camera on. Okay. Mr. Operator, ready?
Yes.
Okay. I will count from 1 to 3. 1, 2, 3. Okay. Let's do the second session photo. 1, 2, 3. Okay, thank you very much. Okay, before we continue, allow me to introduce our moderator for the first session for today's seminar by reading his profile. Dr. Arifin Nugroho graduated as a Doctor Engineer of Faculty of Science on the Rennes 1 University in the field of satellite control, France in 1984. He is a consultant in telecommunication and satellite industry, majoring in the satellite systems, radio spectrum regulatory, and satellite business. He read a lecture on this subject at the Telecommunication Graduate School at the University of Trisakti, Jakarta. In addition, he gives also a lecture on the stochastic process at the postgraduate school at the Telkom University, Bandung. Currently, he is a member of IEEE and assumes this year a chair of the IEEE Aerospace, Electronics, and Geoscience and Remote Sensing Satellite Joint Chapter Indonesia section. At this moment, he also serves as an advisor to the Ministry of Communication and Information Technology on satellite regulatory matters, as well as to different satellite industries. Dr. Arifin has pursued his career in satellite communication for almost 30 years at Telkom Indonesia. He is one of the supporters of the Indonesia Nano Satellite Program for Research and Education, aka INSPIRE, initiative in 2011, and an inter-university organization unifying national efforts for institutioning the satellite technology as subject of research, industry, and education in universities. He is also a founder of Asosiasi Satelit Indonesia, or ASSI, in 1998, a satellite industry gathering. Recently, in 2013, he was a co-founder of the Indonesia-ITU Concern Forum, or IICF, a social foundation which organized meetings soliciting public opinions in regulatory of frequency spectrum and telecommunication standards. He also a co-founder of PT Universal Satelit Indonesia, a startup company which is focusing in the domain of satellite communication services. Dr. Arifin pursues now an activity as consultant for monitoring the manufacturing process of a satellite being procured by certain entity. Good morning, Dr. Arifin. It's my pleasure to meeting you today.
Good morning, Mas Kinan.
Thank you, Dr. Arifin, for welcoming me today with the warm speech.
Thank you.
Okay. The schedule of the seminar will focus on our title, Nano High Throughput Satellite Technologies. It will more discussion to address the full aspects of the topic. I wish this conference enlighten us all and provide us with approaches to deal with the future. The seminar is brought to you by IICF Sub SJ Satellite in collaboration with Indonesia GRS IES joint chapter on the IEEE in collaboration with SBS GRSS Telkom University. This seminar is endorsed by SIA India, ITU, APT, and IEEE, and this seminar is sponsored by Pacific Broadband Satellite. Without any further delay, I would like to ask our moderator, Dr. Arifin Nugroho, to enter the room and lead the seminar. Thank you and enjoy the event.
Good morning. Perhaps there is a very disruptive technology, if I could say, that we are all witnessing the emergence of very high capacity, we call it high throughput satellites, which are getting more and more acceptance to distribute internet and perhaps also non-internet kind of signals to the end users directly. Well, this session is going to be witnessing two speakers, the specialist for HTS. One is Mr. Filial Fahri from Department of Electrical Engineering in Trisakti, and secondly would be Mr. Dwi Cahyono MSc from Germany. I cannot remember the name. Is very difficult for me to remember, but this is certainly is very reputable university in Germany. Let me start off with to let the first speaker, which is Mr. Filial Fahri, Master of Engineering, to come forward. But first of all, let me read the short biography of him. Mr. Filial Fahri is Master Engineering in Electrical Technology, Electrical Engineering from Trisakti University, Faculty of Technic Industry, Indonesia. At the moment, he's also working as a hub NOC and product development engineers at PT Telenet Banten, Indonesia. And he's getting a master degree from the SET University with a thesis titled Adaptive Resource Allocation in Multi-Beam Satellite and HTS. So I think we could go through, but this is a very long story of him. So I believe that it should be enough for introducing him as speaker today. And I would like to ask Mr. Filial Fahri to start with his presentation for today's seminar. Please, Pak Filial.
Yeah, thank you, Pak Arifin. Good morning, Your Excellencies, distinguished First, ladies and gentlemen, good morning and welcome. Especially Pak Arifin, who has called me to this webinar as chair of IEEE, IISGRS, and also Pak Edi Setiawan, chair of IICF, and that I have the pleasure of meeting for the first time today. First, let me start the meeting with expression of gratitude. I will screen my presentation. Okay, thank you. Let me to present my presentation entitled Adaptive Resource Allocation in Multi-Beam Satellite. So this is the agenda for today morning. I will present the first background and continue to see the literature review of the work related and continue the problem statement as a basis of my research, and then continue and the recent research objective. Then we will explain the scope of work and problem implementation, benefit of research, also super theory, and then the core of this research we will simulate, and all of you can see the resulted analysis. And in the last, we will conclude the research and future work that is opportunity to the latter research. Okay, we will explain the background of the works. So in this presentation, we will see the monobeam and multi-beam satellite. So monobeam satellite is has the coverage regional, and for example, AsiaSat 9 and Telkom 3S with the bandwidth limited. And meanwhile, for multi-beam satellite, the coverage is custom. Basically is 100 kilometer coverage and 250 and can go to 500. For the example, in this presentation, you will see the Pacific one, and in the former IP Star one. This type of satellite has the higher bandwidth compared to the conventional satellite or monobeam satellite or global beam. Generally, we can global beam. For multi-beam satellite, must be finishing the problem of the conventional satellite, like because the multi-beam satellite has the capacity wider than the conventional satellite. But in the fact, this is the multi-beam satellite has the problem like in this picture, that the demand override over the supply. So the bandwidth is scarcing. This is the first problem. And the second problem, the bandwidth not efficient because of the between one spot beam and another spot beam. This is there are the different. So this is because the traffic asymmetrical. In the next slide, you can see the. Therefore, we need to optimize the HTS. This is the reason you will see the there are 1 beam, 2 beam, and etc. Until 12 spot beam. There is the beam that is over capacity, big traffic in 6 beam for the example, and for the 8 beam, this is the low traffic. So this is not driven, not different for the capacity. So for this, okay, what is the researcher work in before for optimization the HTS? Generally, there are 4 types. There are 4 types for satellite optimization. In the first, we can approach to the power approach, power base, and the second bandwidth base, and for the 3 joint power and bandwidth. And in the last, and this is the last issue, yeah. So this is hoping. Between 1 until 3, this is use the Shannon capacity base, where the researcher start from the bandwidth or power approach. I will to propose another technique with the adaptivity and microbeam activation. First, we will the technique that is called the user adaptivity. We will allocate the capacity or throughput based on the remote receiver, and in that carrier on by the slicing on beam or micro beam are assigned with the different power level or mode code. For the 1 and 2, we call joint power and carrier assignment optimization, or we can call as user adaptivity or UA. And then we will introduce microbeam activation or MBA to improve the capacity. And we can the final technique we call the adaptive resource allocation combined between UA and IBS. This is for the 2. So we will use the microbeam activation. So in the presentation, you will see the spot beam in there where the beam is split to the microbeam or sub-beam. This is the final adaptive resource allocation technique that is combined between user adaptivity UA or microbeam activation. Problem statement. I'm sorry, research objectives. So the research, I'm to creating a model for optimizing satellite resource and segmentation through separation of satellite subbeam, either power level, bandwidth, frequency intelligence, including adjustment of its section station, as well as combined with optimization of total data throughput using the adaptive module of the its segment station. So by combining these 2 techniques, it is expected to obtain improved performance from the network and increase the availability of satellite network. So we can conclude the objective of research. First, creating optimization model for resource, either power, bandwidth, carrier, spot beam, or adaptive satellite subbeam. And the second, by using adaptive carrier beam or user adaptivity UA, and microcell or subbeam activation, microbeam activation MBA. So we will get optimal spot beam or sat beam capacity, and then increase availability on multi-beam satellite network. This is our goal. Oh, this is sorry. This is the best on that is to be problem segment. In the first, what is the scenario to handle the excess demand on single beam due to fluctuating traffic? And then how to model and analyze beam optimization, where the user will be managed to occupy one carrier according to their power level adaptively, user adaptivity. And number 3, how to optimize the space segment and adjustment by activating micro beam or sub beam, so the capacity can be increased several times by the size of number of activated micro beam. Scope of work problem limitation of the research as follow. The first, the optimization problem is carried out on the Earth sky and sky Earth direction of K band. And the number 2, satellite is assumed to only strengthen on radio frequency side, or can we call as band pipe satellite. And number 3, the problem is only limited to one beam with several beam by following the reuse frequency N4 and subbeam M4. And number 4, the research does not discuss interference between beam and subbeam, co-channel interference between beam and between beams and subbeam. Number 5, in spot beam or subbeam will be installed carrier with uniform bandwidth and different power level in the form of mode-code modulation and coding. And then number 6, the propagation channel are assumed to be same for all users in the beam or subbeam large-scale fading. Number 7, the measurement parameter used are terminal receive level for the adaptive mode code and total demand for microbeam activation. Service that is used by the customer is shared broadband internet. Satellite service is 95%. The proposition will be compared with conventional beam, satellite beam, which has uniform carrier. The benefit of research. The benefit of the research, we will hope to obtain an adaptive beam or subbeam allocation model through joint user adaptivity and microbeam activation to increase remote throughput and increase network availability. Number 2, being an alternative choice among other methods that currently to be the concern of many researchers who use bandwidth, power, combined bandwidth, power or beam hopping in optimizing analytically or with the tool of artificial intelligence. For the background, for the support of theory research, we can you will see the multi-beam satellite communication model, in which we can see the segment from remote or remote to satellite. This is using kabel. Meanwhile, from gateway to satellite, we will Q or V-band for the bigger reason. This is the layout and frequency use modeling for beam and subbeam on multi-beam satellite. So you will see that this is consists of the number of spot beam, where in the inner beam this is consists of the subbeam or micro subbeam. This is N or M equal 7. This is the metric performance for our work, that is that are SNR, efficiency and throughput, which the more SNR the remote, the more the efficiency and throughput will be get. We will try to see the simulation. So this is the layout model from the from our work. So the beam is consists of the spot, many spot, and many sub beam or subspot or micro beam satellite. Where in this region we will use only one beam and 4 sub beam. This is and then we will try to channelize frequency in that from the spectrum, total spectrum that exists, such as 2 gigahertz. We will divide in 7 or in 5 frequency in this picture. We divide to be 7 frequency of it. So the total bandwidth of each beam we can get around 300 megahertz. We will continue to simulation process. So the step for the simulation is consists of the first we create adaptive layout model, and number 2 we will allocate a frequency channel or frequency reuse, and also bandwidth of each or sub beam. And number 3 we will create a multiple carrier on beam or sub beam. We will can 4, 5 depend on the design. And the number 4 we assign multiple carrier with combination, modulation, and coding in their carrier. And number 5 we will activate remote communication on beam or sub beam for the all remote. And we will try to remote check connection, and the last we will throughput calculation on beam or sub beam. Okay, and the next step we will see the implementation, testing, and analysis. So number 1, we will create adaptive multi-beam satellite layout by adapting the Papua Pacific one with coverage diameter of 500 kilometer, or an antenna beam with 1.8 degree. In increasing the capacity of satellite, micro beam with diameter of 300 kilometer, or a beam width of 0.5 degree is activated. In the implementation phase, only 1 large beam and 4 sub beam are used, which each sub beam having a capacity of 1 multiple 500 megahertz. Number 2, we will model frequency use on multi-beam satellite with different frequency to eliminate interbeam or sub-beam interference. However, in the simulation, interference is not taken into account. Frequency reuse is done with concept of coloring or frequency combination following the reuse pattern of n equal 4 frequency. Coloring will prevent interference between beams or sub-beam. However, if n is greater, the available bandwidth will be smaller, thereby reducing the throughput. And then we will allocate channel bandwidth on each beam or sub-beam. The total bandwidth of 2 gigahertz is divided equally across 4 beam or sub-beam, so that each beam or sub-beam get 5 megahertz, or 2 equal 2 multiplied by 500 by applying dual polarization. Then we assign a multiple carrier on channel bandwidth uniformly in each beam or sub-beam in order to remote get 50 megabits per second in the bandwidth. The minimum carrier width provided is 36 megahertz, assuming the mode code content is XPSK 23. But in practice, the more remote access the network, the smaller the potential to get large bandwidth. With available bandwidth of 5 megahertz, for carrier with a width of 1 to 2 megahertz can be made that are possible to create in Ka band system. And number 5, we will set up multiple carrier with a different combination of mode code. The thing that must be considered is that the system must provide opportunity for the remote to be able to access to the network with low power or low SNR, whether it's due to a decrease in performance or due to channel propagation condition. So the combination of coding and modulation is made starting from the lowest level. For the example, QPSK 3/4 to 16 APSK 9. And then we try to activate communication of remote station to access the internet by generating random remote traffic in beam or sub-beam or micro-beam. The location of the remote in this simulation are predefined. In this section, the link budget is calculated to get the value of remote reception power quality. Through the power control mechanism, this SNR is reinform back, feedback, or piggybacking to the satellite via the uplink channel, and according to the SNR, remote will be placed on one carrier according to achieved mode code. If the remote SNR does not reach the lowest SNR limit, the remote will be disjoined from the network. Traffic demand is randomly fluctuated between 1 megabit per second to 50 megabit per second. SLA specified for a 95% shared broadband internet. Number 7, we'll perform remote throughput calculation per beam or sub-beam to get the total throughput on the system. The value of remote throughput per beam or sub-beam can be calculated through the distribution of carrier in the beam or sub-beam. Through this assigned carrier, remote distribution can be known via mode code occupied. Remotes that occupy high mode code are bandwidth hungry remote and vice versa. In addition to the throughput calculation, remote availability is also calculated, either join or disjoin remote into the network. Number 8, if the bandwidth or capacity of test reach maximum, the algorithm decide to activate sub-beam or for sub-beam, for the example, depending on the traffic demand in one area. In this case, all remote try to synchronize a new channel with larger capacity. The system will monitor continuously to decide to return to the previous spot beam by policy of loading capacity and number of switch time. Number 9, assign the same mode code or uniform carrier mode code to the beam and compare it to the point 4 to determine the total system throughput and remote availability. By looking at the result of the difference between point G and I, it will be seen whether the adaptive multi-beam satellite model is proven to have advantage in the term of increasing capacity and availability. This is the implementation. There's this resume in previous slide. This is the layout model. We take Papua beam, such as for Pacific band. We take the beam 1 in the West Papua. There is 4 microbeam, sub-beam or microbeam 1, 2, 3, 4. This is the frequency used and M equal 4. Also for the sub-beam, we will use the frequency used for. So there are 4 beam, beam 1, beam 2, beam 3, beam 4, all of beam covering the Papua. This is the bandwidth location on the beam. So for the 2 gigahertz that is available for the downlink in the KA band, we divide to be a 4 beam. So each of beam can get 500 megahertz. And then we will assign a multiple carrier on the bandwidth channel where we divide the total 500 to be 4 multiple carrier. So for the each carrier, we can get 122 megahertz, 122 megahertz. With the different setting mode code to get the different SNR or power level on the remote. For this picture, you will see we set the mode code starting from the lowest to the higher mode code, 16 FSK X9. And then point to be consideration of point this point C and D. I'm sorry. In order for increasing or decreasing level is constant 2 dB, except for lowest mode code QPSK 3/4. That is to accommodate low power remote. As table from GLAD system. I will give the block print in this picture. This is the total throughput we can get from the different carrier mode code from the starting the lowest mode code QPSK 3/4 until 16 APSK over 9. The total throughput can provide base system within the different carrier. We near 1 gigabit per second. And then we will activate the remote access in this picture. We will use the Cubesat band at 150.5 is degree. So the remote will be activate the application, for example, using internet. So we can calculate the throughput, total throughput, as we can see in the next slide. For the link-based calculation, we will assume the satellite Cubesat band with the transponder saturated power 30 watt, and then antenna gain axis similar to 6 meter KASAT. That is give the gain is 50.6 dBi. So and transport bandwidth must be 500 megahertz. So for this length budget, we will get the SNR around 9 until 14 dB. This is enough, big enough for the remote quality of remote. And then we will generate the user traffic. We assume the number of sites 100. That is separate split from West Papua, subbeam 1, subbeam 2, subbeam 3, subbeam 4. Traffic pattern move from 1 to 50 megabit per second. So from the preparation simulation, we can result the as follow. As you can see, the remote calculation per beam from the 4 sub-beam with the set different mode code, as we explained in the earlier, we obtain near to 1 Gbps. So this is the traffic demand from the 100 remote. This is until 2. So the demand is bigger than the capacity, maximum capacity of the system. So for this reason, we will need to activate the small beam or micro beam or sub beam. In that, we will only simulate the beam 1 and beam 4. That is the demand the difference between of them. Beam 1, the demand is 1 gig, and meanwhile for beam 4 is 800. So with this, because the small beam is has capacity with spot beam, so we can get the capacity is double fold from the spot beam. So in this, this is the resume for the previous slide. So the bandwidth request for beam 1 and beam 2 near to 2 gig. Meanwhile, the bandwidth allocation can provide must be 1,700. This is the advantage of the small beam activation or micro beam activation. And we will see the capacity analysis compare with the homogeneous carrier. So we will compare between different set carrier and homogeneous carrier. In this slide, you can see the capacity of the different set carrier with homogeneous carrier. That is bigger than. So we can advantage with average of 10%. We will get advantage of 10%. This is the resume. So the bandwidth request for the standard beam until 2000. Meanwhile, the capacity that is provided to the remote is only 1,000. Meanwhile, from the homogeneous carrier, the demand traffic is 2,500, and the capacity can provide to the remote, to all remote, is only 800. This is long. This is very long, yeah. Okay, so this is we can conclude from the previous slide. Number 1, the application of adaptive resource allocation as a form of optimization has proven to be successful in increasing the capacity of multi-beam satellite. And then adaptive resource allocation is a combination of 2 adaptivity techniques, namely adaptivity at the first level in the form of grouping remote on outbound carrier, but on satellite or gateway based on the level received remote. This adaptivity is known as user adaptivity or UA, and at the second level, namely micro beam activation, as adaptivity to respond to the lack of capacity in the beam by activating the sub-beam. Number 3, by using remote adaptivity or user adaptivity, it is proven that there is an increase in capacity of 9%, or I just call 10% compared to the mode code uniform carrier. Or Number 4. In addition to the increasing capacity, the application of different carrier in the study provide availability increase up to 100%. By setting different mode code carrier, the availability factor reach 100%. Number 5, microbeam activation can increase capacity by multiply of activated subbeam. Based on the simulation reset, the capacity increase for the activating 2 subbeam is 87%. And then number 6, capacity increase depend on the traffic demand. If demand is close to equal to a maximum capacity, capacity increase is up to 100% for activating of 2 subbeam. In the event of the traffic demand exceed the capacity of the subbeam, the system can only serve requests according to maximum available capacity. Then the system will define the capacity based on the QoS or each remote based on the priority, or will use the best effort mechanism. So and the number 8, mode code carrier setting have a big impact on increasing capacity. And then carrier with low mode code are useful for accommodating remote when there is a significant effort. In this simulation, because of the condition is clear sky, so the all remote near to achieve the highest mode code. So the low mode code is empty. So we can get 100% for all remote to achieve the highest mode code. And number 10, remote adaptivity allowed to be implemented for now in the form of software upgrade, for example. And number 11, splitting bin can be practically implemented using backup gateway, so that in addition to main gateway or diversity, a backup gateway can be created to activate the subbeam without disturbing the capacity of main gateway. In the last, as with the beam hopping technique, micro beam activation occurs in the time and spatial domain. However, when beam hopping takes place between beam, meanwhile, the performance of micro beam activation occurs between beam and subbeam, which is located inside beam. The future work, this is to be planned for the in the future. Number one, research by taking into account the interference factor between the subbeam or inter-subbeam interference and between beam and the subbeam. Number two, trying to compare the beams splitting or micro beam activation performance with beam hopping that consider both method take place in the same domain, either time or spatial domain. Okay, this is the bibliography. Okay, thank you for the presentation, the first presentation. Terima kasih, hatur nuhun Pak Arifin. We will come back to Pak Arifin. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, Pak Billy Al-Fahri, for your comprehensive presentations. It is very, very interesting expose, and you have very detailed presentations. It should be very, very interesting, and especially I see that your work could be, I think, could be implemented in view of the dynamics of the traffic, and still using the same frequency band, but it needs, of course, elaborations it seems to me, elaborations, both in the satellite sites, because you are making some kind of changes between normal beam and micro beams, and according with certain criteria, when are you going to do that? And secondly, also you did take benefit of, it seems, the mod code and so on, meaning that you are going to make use of the spectral efficiency benefits, because you are having a higher EIRP, and it seems you are going to use what you call it, such EIRP to be increasing this spectral density. Anyway, this is very, very great job that you are doing. There is a question, however. Let me go through it. Question: for adaptive beam, 1, create by ground station, but beam spot model by satellite. This is exactly what we have all in mind, correct? Could you let me go through. Now, number 2, problem for adaptive used MSMNT. I do not know what it is, and link live RTO. Maybe Pak Kestoro could explain this. Number 3, right and left hand circular polarization use fixed, but for change constraint remote down. For capacity design, beam spot by satellite. On real implementation, use capacity beam plan by satellite. Could you kindly elaborate this question, Pak?
Okay, Pak. For the first question, so we can implement the adaptive resource allocation either in hub gateway, in ground segment, or the satellite, Pak. So this is possible. So for implement in a satellite, I think this is there is the technology can be used for in satellite implementation. More in currently this is the technology that is called is regenerative satellite. I think like that. And number 3, I look the GLAD system, the new GLAD system that is based on S2X. This is the hub is consists of more than one part, more than one outbound. So such as for the example, we will set the 2 outbound. So how to change to switch from one outbound to the second outbound? I look actually there is interrupt, Pak. There is interrupt minimal a minimum of 10 seconds until 10 seconds until 10 minutes. Correct me if I wrong, yeah. So there is I think for this implementation this is possible because of GLAD. GLAD is available, is ready for the implementation for this method. And the number two, I'm sorry, Pak, can you repeat, Pak, for the question, Pak?
The number two, stated here, problem for adaptive use and link live / RTO. Pak Kistoro, maybe you may need to explain what is your second question. Could you speak out?
Okay, thank you, Mr. Arifin and Mr. Faisal. I mean, question two, adaptive usage. I mean, experience. Change the system down, link down session remote, not hub. This is how to millisecond or how to manage. But Mr. Farisal, yes, answer to 10-second RTO for until if your statement asks. I mean, Pak Arifin, makasih. Thank you.
Okay, thank you, Pak. Iya, 5 RTO gitu, Pak.
So, Julia, Pak Julia, do you have any comment on that?
Yeah, I think enough, ya, Pak. So, we will see the GILAT system, ya, Pak. I think this is a start from the technology, radio technology, point to point, that is using the frequency in 5/8 gigahertz. I think this is the system consists of the more frequency channel. So in one channel or more channel crowded, the system will switch to another channel. I think this mechanism can be implemented in the satellite, such as in Ka-band, that is used for generally to for internet area, for internet, except for the banking banking application. I think this is not possible, Pak Arifin. I think
okay. Okay, I hope that answers the questions of Pak Kistoro. And number 4 is capacity design, beam, spot beam by satellite on a real implementation used capacity beam plan by satellite. Pak Kistoro, again, please kindly, please kindly explain your question once again.
Okay, thank you, Pak Arifin. For the question 4, capacity design spot beam created by satellite operator. In real implementation, if uses sat beam, plotting by design from satellite operator. But if you user or remote using the change pin, this question for question to operator satellite, for we using number pin for the usage, but sub pin usage many pin. I mean question number 4.
So it means that's the operator should be the satellite operator should be collaborating very closely with the VSAT, in this case VSAT vendor, in order to be able to implement, for example, the adaptivity whenever a smaller beam or micro beam would be so required, isn't it, Pak? Pak Kistoro?
Yes, correct, betul Pak.
Okay. Okay, thank you. Thank you, Pak Kistoro, and thank you, Pak Filia. Now, let's move on to the next question from Sabri Khairul. The question is, how do you define main beam area in Papua case? Why are there several sub-beam with some number? Why do not increase the number of sub-beam? Pak Filia?
Okay, yeah. So the sensing to activate the subbeam, we will see the total demand throughput. If the demand throughput is more the maximum capacity, so the system will activate the subbeam. The subbeam. This is
Okay.
for the research. We have only activated beam 1 and beam 4, but in the actually maybe the calculated is complicated. Yeah, but this is the simple example.
Okay, Pak Filia. While we are waiting for another question to come up, could you explain whether your simulation is based on clear sky condition in this case?
We will give the attenuation, Pak. So we will attenuation from 1 until 6 dB to simulate the rain attenuation in country like Indonesia. I get the similar criteria from the USA, that is same the condition with Indonesia, that is give the attenuation for rainfall 1 until 6 dB, Pak.
It seems to me that 6 dB is and for Indonesia is rather low.
Yes, Pak.
It can be a lot higher than that. So meaning that it is still interesting in simulating what will be given by your system, your adaptive system, in getting more capacity whenever there will be a rain fading. What is your comment on that?
Yes, this is the typical for rainfall, but maybe we can implement the IUPC for provided the spare of attenuation like until 10 or 20 dB. So this is for spare if any rain in Caribbean. Such as I have ever see for the Caribbean is until until 20 dB, Pak. Yeah, we have carrier until 20 dB if any rain and there is a drop at all. So I think for the Caribbean system that is typical has rainfall until more than 20. I think we will need to provide the gain with more than or same the 20 dB.
Okay, and hopefully this afternoon there will be a relevant discussion regarding the subject that we are discussing now, especially whether in the field there is lesson learned from the existing networks, so that whatever mitigation they have made, there should be a kind of a tacit information for everybody, for other user or other operator or VSAT operators, in view of getting better quality of service as far as internet is concerned using satellites, and especially if we are to use the Ka band. Okay. So is that true, Pak, that in this case the smaller beam, which may create a bigger AIRP, will be a fundamental for increasing the capacity by using a mode cut? Is that the principle? It seems to me yes, but please please make your comment. So in this case, you are utilizing mod code, right?
Yes.
So you are exploiting mod code in your simulations, but that will certainly be functions of the AIRP, but the AIRP is also will be depending on the size of the gain or the antenna gain in this case, correct?
Yes.
So is that true that the philosophy behind is because of the of the things that we have been discussing just now? What do you think?
I don't accept, Pak, your komentar, Pak.
Yeah. Okay. Yeah, there is a question from Edi Setiawan. Can you provide a copy of your presentation to the committee? I would like to ask another question regarding that. In many places, you mentioned that you are ignoring for this moment the interference between the beam, which is in my opinion, should be, well, we should precaution in doing such kind of ignorance. But what do you think? What do you think in this case regarding the C over I? And if it is, what is the grander? And what is the size, more or less, this the typical size of C over I that one can find out during the operation?
Okay, Pak. Actually, this is the challenge, Pak, for the implementation of sub-beam in the beam, Pak. I think this technique is near similar to beam hopping, yeah, Pak. But if beam hopping, this is of course between beam and another beam. Meanwhile, for the adaptive resource, this is occur in the same beam in the inner beam. This is the challenge. And I think for the beam hopping, this is not finished, Pak. So the simple technique for mitigate this case, I think we can use the configuration between right and all HCP, Pak. In the earlier, we can implement differences between different polarization. I think this is can be implemented in the early phase, and the next phase, I think this is can be mitigated together. We will what is the another technique to mitigate this?
Pak Filial, I'm going to ask you regarding what should be the trigger to use or to activate your algorithm. Are you going to put some kind of quote unquote alarm in your what you call it in your software, in the, for example, in the switching? So whenever there is a traffic, should there'll be an excessive traffic, then there will be maybe another delay phenomena. So in any queuing, for example, if you are having blockage, meaning that the delay may be high and something like that. So what will be the mechanism in your mind for having a trigger?
Yeah, since the sensing parameter will use the demand traffic, Pak. So I think the system in layer 2, in layer 2 after the RF baseband on the processing the related to the radio frequency. So the system in layer 2 can calculate whether the demand traffic is lower or is more than the maximum capacity.
Okay. Is there any other question from the audience? If any, you may wish to ask Pak Filial directly by using reaction. You just key the necessary sign there.
Pak Arifin, may I ask Pak
Yes.
Filial?
Sure. Please, Pak.
Pak Filial, this is interesting for your presentation this morning. Can you hear me clearly?
Can you increase the your voice, Pak? Your voice, Pak.
Sorry. Hello.
Okay, ya Pak. Okay.
Okay. It is interesting to follow your presentation this morning, Pak. Talk about the micro beam, beam, and you use specific beam to be model for the simulation. Maybe continuing Pak Kistoro question, I would like, are you consider about the switch over from the existing beam goes to your micro beam
on the during on conversation, during on traffic on, let's say, maybe there is a 99 or the user number 99 during his to use the link, use the internet, in the moment is suddenly they get situation that the spotting that they use is fully or crowded or near to collision. Yeah, so your system will be changed to micro beam that this is will be upgrade the capacity until twice. My question about how this switching from the big beam goes to your micro beam. As you mentioned, this will be happen on the hub. I just curious how the system knowledge and should be changed over to the micro beam when the traffic is on the user number number 99 or number 2 lah. Yeah. Just curious because when the user is using the traffic or in the engines, he has a frequency itself. Yeah, he has a working frequency or he attempt a channel, and when he goes to another a beam, another another beam, he should location update. Let's say location update or what else to goes to another frequency. I think this is not simple, yeah, for in my mind. Maybe you can explain it the method
Okay,
for
Pak.
that, Pak. Thank you, Pak.
Yeah,
Pak Arifin.
the first the system will be not the lat and long, Pak. Yeah, lat and long in the system. So if there is one remote will be handled by the subbeam, so the hub is no problem again, yeah, for to manage this case. So as previously we explained, so the hub, the sensing is by using the traffic total, and combined with the location area. So the policy is if the demand traffic of all system in one stop, for example, is more than the capacity maximum, the policy is change to subbeam. For example, one beam 1 and beam 4. And then for the second policy, if the capacity, if the demand traffic of the subbeam is near or close or reach to the maximum of the some maximum capacity like the spot beam, that the system will limit the maximum capacity. This is no option. Yeah, there is no option again for the second condition. So the policy is will give the priority either or QoS or best effort, or the whatever the priority we will set before. Like this, Pak.
Okay, Pak. Very well. Okay, I think it's enough for now. Let me think. Go ahead. Thank you, Pak.
I'm sorry, Pak. Can you increase, Pak?
Pak, suaranya.
Okay, I can accept it right now. Let me think another in future. And yeah, thank you. Please go ahead, Pak Arifin.
Okay. Thank you, Mas Sugeng. Speaking about the switching or whatever, people now is using IP router or whatever, or IP processing or whatever. Now it seems by having this kind of algorithm means that there will be a more traffic passing through the satellites, okay? And then subsequently, there should be also tight collaborations with the design of the switching themselves, especially the one being put in the gateway, correct? In other words, there should be doubled, capacity should be doubled, or I don't know, but of course there will be costly, but this is the consequences. This is the consequences of having more traffic, in order to have better performance as far as traffic is concerned. Then, for example, we might detect the delay being experienced by certain certain what's it called, block of data or packet or something like that. If the delay is increasing, meaning that the capacity, what you call it, the switching capacity should be revisited, and so on and so forth. Is that true, Pak Vilya? In this case, so we have to be careful with applying such kind of algorithm to always link up with the the capacity of the switching itself.
Thank you, Pak. Yeah, for the additional answer, Pak. Yeah, this is very, very supportive, Pak.
Okay. With your Pak Vilya, with your simulation, what you call it? What the end capacity can be reached using the same, say for example, frequency band? What will be the result in applying such kind of algorithm, according to you? Double, triple, or something like that?
This is depend on the microbeam that is activated from Asia, Pak. So if we have for microbeam, so in the exactly without the interference factor, for example, and another, so we can get the capacity similar to the number of the microbeam that is activated. This is the excellent capacity, but I think for the future work, we can consider the C over I, that is S over I, S over I, that has the contribute to the degradation of the capacity.
Okay, Pak Filial, time is up. I'm afraid time is up, but still your subject is very, very interesting, and especially this kind of idea should have been put into considerations for the planner, and especially those who are doing HTS along with the VSAT implementations for a big network such as HTS. It should be worth looking and worth considering the very algorithm that you are proposed. Congratulations, Pak Filial.
Yeah, thank you,
And,
Pak Justin, for
yeah.
the time, Pak. Okay.
Yeah,
I
thank
will
you.
close the
Yeah.
I will
Okay.
close the
So, ladies and gentlemen, we end up with the presentation of Mr. Filial, and I hope that his presentation will be inspiring everyone who do the planning in the satellite business, and especially with regard to the the need of adaptivity, which is always happening one way or another, because people are moving, people are having different purpose or different occasion, and so on and so forth. Thank you very much once again, Pak Filial, and I would like to return this platform back to the MC. Thank you.
Thank you, Pak.
Hello, hello. We cannot hear you.
Okay. So thank you, Mr. Filial Fahri, for the topic that you lead us and you teach us. And before we proceed to the next speaker, we would like to show a short video of our platinum sponsor, Pacific Broadband Satellite.
Perkenalkan, saya Jamalul Iza, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet, gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau, gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya dan bekerja sama dengan ASN ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah, ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital. Dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi.
Okay, once again, I want to say thank you very much for our platinum sponsor, Kasifik Broadband Satellite. And for Dr. Arifin Nugroho, please continue the seminar session. Thank you.
Thank you. Okay, let's go into the second speaker. And permit me to to read of his short biography. Our next speaker would be Mr. Dwi Cahyono, Master of Science. He is an EMC engineer. EMC is electromagnetic compatibility. I think, okay. So Dwi Cahyono has got a Master of Science degree in the Embedded System Engineering from the University of Duisburg, Essen, Germany. Do I spell it right? Hopefully. With courses and research on the wireless communication, signal processing, microwave electromagnetics, antenna, millimeter wave, terahertz, communication, Internet of Things, embedded hardware and software. And he got a master degree because of his thesis entitled Impact of Antenna Directives on the Terahertz Channel Model. This is a very, very interesting subject along the line with previous speaker, although indirectly, but it might be related in the future. But actually, his master degree, the first I have read, is being obtained in 2018. But in 2016, he got also previously a Master of Science degree in Communication Engineering from the same university. And he has completed 80 credits toward his MSc in communication engineering. But of course, everyone in Telkom University mostly knows him. He was he is an alumni of the school, got Bachelor of Engineering and Telecom Engineering department with course and research regarding nanosatellite, communication system, signal processing, antenna, electromagnetics, mobile communication, and communication network. His bachelor thesis was design and realization of onboard data handling for remote sensing payload of nano satellite FPGA based. Without further ado, I would like to invite Mas Cahyono for delivering his presentation. Mas Cahyono, please.
Halo Pak Arifin, Assalamualaikum.
Waalaikumsalam. Tambah ganteng.
So long time no see, Pak Arifin, and to meet you since I don't know 2000.
Handsome, and handsome now. Yes, you have plenty of time. Please do your presentation as much as you like. We got plenty of time. Okay, please.
Okay, just let me share my PowerPoint. It's clearly, you can see my slides or?
Sure.
Okay, right. Yeah, I think I don't want to waste my the time, so just would like to start this little bit research what I've done in the past, and I hope this will be like you know, elaboration between this research to what Pak Arifin asked me to relate in the nanosatellite purpose, especially in HTS. Yeah, I'll bring the title of this presentation about terahertz antenna design and misalignment for a review for an nanosatellite purpose. Okay, right. So in this presentation, it would be what is the terahertz, and then overview of the terahertz communication in a nanosatellite, or I think in the general communication system of terahertz, and then the terahertz short communications. In this way, I did in simulation in room communications. So just let you know if there will be a connection to space communications in the future. And then there are heads antenna design, of course, and additionally into the antenna misalignment and phase array as well for terahertz antenna. And yeah, let us go to our first slide. So what is the purpose of doing in terahertz band or terahertz frequency band will be, or sub-millimeter, I would say, because it's in between 300 gigahertz to beyond 1000 gigahertz or something. So it's really high frequency, and I think nowadays in worldwide, or I don't know in Indonesia, but in Europe or USA, it's really getting more resources in these terahertz, especially in terahertz communications. So it will be maybe insights for you guys. Okay, then this is the wireless communication roadmap, especially for mobile wireless actually. So, from 1995, it was with GSM or something with very low data rate, and then goes to in the future, let's say 2020 or 2030, even with 100 times from cellular to WLAN, and it will really help to getting our proposed to have really high speed in getting the data rates, because nowadays so many applications, such as what I'm doing right now in automotive industry, is like needed in the order of gigabit per second or even more right now. So I think in the space or satellite technology, of course it will be required more and more data speeds to gain more data, what we really needed in the future. So our goal is how to have gigabit per second, or in the order of terabit per second even. So it's really, I think, really long roadmap from today to, I would say to 20 or 30 years later on. As I said, this terahertz communications is really famous in in-room communications or short-range communications. Saying in European application, or I don't know, in USA, there are several researchers in, I would mention, like in Georgia Institute of Technology or something. There is one professor who is doing right now as from the indoor communication to space communication. So it's like Internet of Things to Internet of Space things, if you ever heard before. So this terabits per second link will be like the goal of all this wireless era, I would say. Okay, then what is the promise or even the challenge in this terahertz frequency band for communication? So of course there are many actually the benefits, and the opposite direction to the challenges, of course. So this terahertz band provides an confidently reach the data rates of up to 100 gigabits per second, as I mentioned before, and this can be challenges simultaneously providing lots of benefits and applications, as you can see there. The benefits will be like, large channel bandwidth with what I'm wanna say in this presentation is will be like more than or with at least 50 gigahertz bandwidth. So it's really quite a lot. And then we can achieve the really high antenna directivity, antenna gain, and then with tiny structure, it's a really small structure. And right now, I read before from the material point of view, there is a graphene or something that will be really have benefits in this terahertz frequency band. It can be really tiny, and I think it fits to nano satellite application with a small satellite in the future. And of course, the research challenges will be like how to have the channel modeling, and then how to design the terahertz electronics. And yeah, now there is a terahertz gap, what we usually mention. It's like power transmit only with 1 millimeter watt, 1 milliwatt, and then so this gap is like because we are still doing with this research in RF of terahertz, and then with this high gain antenna, so how we can really using it into beam tracking on or beam sourcing in some methods for adaptive beam. Okay. And then if you go to space applications, so there are several applications what listed on the picture there. So one of there is inter-satellite links. So the communications between satellites will be, yeah, typical more than 1 kilometer. I think Pak Arifin is doing more in inter-satellite links till now. Okay, then let us discuss with Pak Arifin about it. And then so that's why I'm going to having the purpose of this antenna design to how to bring it into ISL applications. And then the next one will be the overview of terahertz communication in space, especially in nanosatellite. So the terahertz link, this is based on one of the paper in from CFAS and OSCUR, what they have done research there. And the terahertz link will be both sides in terrestrial and space. So with the macro scale and nanoscale in terrestrial, and the space will be deep space communication, and as mentioned with intersatellite link. Yeah, so many researchers in deep space communication, for example, deep space networks, what NASA is doing it right now with macro or something, macro satellite, yeah, macro Cubesat, I think. So and then intersatellite link, now even China is doing it as well, but I think European is like little bit one step back to those countries, USA especially. They are really so many researches that they have done in deep space communication and ISL. And then the terahertz system have laser beam pointing requirements compared to fiber optics, fiber links, since we consider larger wavelengths. So in the FSO, communications are also highly affected by atmospheric conditions such as clouds, fog, or atmospheric turbulence. Yeah, I have to mention one of the paper. They said like attenuation because of fog could be like 350 dB per kilometer if the distance of if the fog distance can be seen into the distance of 50 meters, it will be like very high attenuations because of it. And then terahertz comes to weather effects in general, and the large terahertz antenna arrays enabling extremely high gains to overcome the, as mentioned, very big attenuation in terahertz links for long distance communications. And then the terahertz waves are not affected by turbulence in those scintillations, which is observed as intensity fluctuations at the signals. This is getting more in FSO links. So what listed there is like the benefits or the benefits of terahertz then using FSO. I mean, it will be not 100% we're choosing terahertz, but it will be alternative to having like hybrid applications. So hybrid means the communications scenario, as you can see in the picture. So in between Earth to space link or space Earth to space communications will be like with the terahertz link can be, and then to another deep space communications with terahertz as well, or space to Earth to space with FSO or something, and then interest ISL with terahertz communication. So this hybrid scenario will be like I think getting more or good application to the future. So several applications, including space observation, Internet of Things, and maritime monitoring, can be done with those scenarios. And then terahertz communication capability can be integrated into FSO communication, as I mentioned before. So it will support the high data rates. Okay, then we're going to overview with the terahertz inter-satellite links. So the communication link between satellites that lie outside the Earth's atmosphere, it will not suffer by molecular attenuation, as we know, all of us. And it's different between optical band and terahertz band would be like with the strictly beam alignment for FSO, and then it's like better. That's why I mentioned terahertz band is more robust than FSO because of this alignment. So it should be with a wider beam width, with, of course, with the phase array scenario as well. So along with the large bandwidth that is currently not available in the lower bands. So the terahertz band is one of a good candidate to be employed for the future ISL. The challenge, and here will be some solutions in this drawback, I would say, like molecular absorption loss, because of on the Earth there are vapor material or water vapor material that cannot be avoided by human. I mean, it's given now. So what some researchers have done is like how to map it, this molecular absorption, or for example the vapor water mapping on the Earth. So the less this molecular is on the north side of the Earth. So if, for example, in Indonesia, it would be really high, so having really high loss because of it. So if we really would like to implement it, I would say to just go to the north, for example, Mongolian countries or something on the desert. So it will help a lot to have really or less loss because of it. And then high and low altitude platforms, hybrid ground to satellite links. And these dry ground sites will be related to the molecular absorption loss. Indonesia has, it's more wet or water on it, right? And then spreading loss and spectrum sharing will be like, it's not in terahertz band. It's not ruled yet for applications. So what some countries have done are like with the observatorium and remote observation for space application, I think. So the terahertz band itself still openly for many applications. Then I will bring this one of a paper from Nordic research. It's about 60 satellite communications. So it relates to the next satellite communications application. So with the social, like human-centric approach, supports good life, of course, with the, if we have very good data rates, we can use it for all the things positively, provide services, also develop to developing countries. And then from the economic point of view, economically will be improve and better and affordable for the user, standardized system for interoperability. And from the environment point of view, the pollution mitigation and climate action and energy efficiency will be there as well. I think Lapan is doing all of it to provide all the things in space technology. And I have to mention this in the annual of space business related to 5th or 6th generation of communication system is expected to grow more than 500 billion euro in the Europe, yeah, for the next 2 decades. It means that it's really promising scenario of the 6G in satellite communications. And the satellites, number of the satellites is increasing, especially in LEO orbits. Yeah, it's like what I'm seeing right now is in the European, from especially in Germany, these LEO satellites, for example, from the senior high school to governmental point of view, they are starting with this really massive. So I would say Indonesia has to be improve in this way. I mean, from the research point of view to production as well. And then spectrum must be allocated and used in a way that doesn't endanger existing services. Yeah. This is related to previous page about the applications. Yeah, if we really want to mix between low Earth orbit into geostationary orbit with the inter-satellite links or something, it can be done with, of course, resources from many sites. Yeah, and then we can have applications such as autonomous systems, communication on the movement, for example, on the train, with the train or automotive industries, and etc. And then in the maritime point of view, digitalization will be required for all the things in our life, right? And then space safety and public safety will be like interesting point as well. And military use, of course. Yeah, I would say this broadband and internet communication will be like really required for having the doing the applications to many sectors, yeah, especially in industry and of course for the people itself. So research topics related to this space safety in the 6G era. What one of these paper mentioned is like how to bring it into some of these applications, such as space traffic management or debris detection avoidance. This, I don't know, in Indonesia or Lapan is doing it or will be doing it, and then automated collisions avoidance procedures have been proposed to be used for satellites in LEO constellations in order to make them react rapidly to threats. And then yeah, space debris is right now a big problem because everyone would like to launch every satellites or rockets or something, then it will be not good for on the space. So this can helpful to detect the debris itself. Yeah, keeping on the space not fully of debris, and then keeping the mega constellations up to date with continuous launching of new satellites and re-entrance the satellites at their end of life to the atmosphere should not cause too much harm to the atmosphere. And yeah, we'll go to the next slide. So in terahertz communications, especially for space applications, I'll just bring it to the little bit to the not little bit one step to the back in the room communications. I'm sure it will be like insight to next implementations from this in-room communication to space communications. So in this graph, there will be some points from the signals point of view, antennas, and terahertz channel, and what is the channel characteristic impacts in this terahertz in-room communications. And at the end, it will be like how to have this scenario in between TX and RX, and what is there in antenna misalignment should be with the phase array to overcome this or something else. So the channel model of this in-room communication will be from Saleh Valenzuela model. So yeah, in the future will be, I don't know if the space communication should be with the another channel model. So let me just overview this, and then we will elaborate to the space communication. So in this point, because in-room communications has a lot of characteristics or yeah, points that we have to be considered. Like room is with a smooth material. I mean, environment with the smooth materials or with the rough surfaces or something. In terahertz band, we have to really carefully consider with this. So yeah, there will be reflections, scattering, diffractions, and etc. And for every scenario, it will be like we have to consider this reflection coefficient, for example, into the material itself. So, for example, reflection coefficient from the TE mode and TM mode, and we have to consider this as yeah, from the angle of departure and angle of arrival there, and yeah, we can really see it for the next slide. and scattering a rough surface with the specular direction. So it means from the Tx to Rx can be done with the wave that that goes to one point, for example, on the rough surface, for example, on the wall, and this considered as specular direction if the angle of arrival and direction, arrival and departure will be the same. And then, yeah, there is one more parameter, and regarding the scattering, it's diffuse when it is not, as mentioned, when the angle is not same or it's directed to another positions or another directions of waves, so it will be like diffuse scattering. So the channel model was done with the realistic small office room, and then we considered only first and second order reflection. And the first scenario is with omni to omni from Tx to Rx. So as you can see there, the material is, yeah, it's mixed. It's within the real room will be like there is wood and for example PVC or plaster on the wall or something. So we simulated in this frequency band. The frequency center was with 350 gigahertz. So we would like to really know how the channel model will be in this frequency. And yeah, the room dimension is only less than 5 meters. Yeah, after simulating, so for your information, this simulations was done with, I mean, we made it, this simulator scratching from 0. So this simulator based on ray tracing method, it means the wave is going to, we want to make this wave to make like image in the image theory. So if wave is coming and then there is an image of these waves behind, and then it's reflected to another, for example, to another direction, and it will help us to have this reflected wave into channel CIR or channel impulse response, and then receive power or something else. So based on this simulator, we can see this first and second order reflections, as you can see there. With the first order reflection, we can achieve a couple of, or there are only 2 waves with the highest receive power in between Tx and Rx. And of course, we have the loss waves, line of sight waves. Okay. So simulations of this in-room model, and we will get these parameters of yeah, I mean, this is very important parameters that we have to do. So angle of arrival and angle of departure. So this spatial modeling channel will be with the 5 clusters, including, if the room there is a ceiling, so we include it into 5 clusters as deterministic model. And then angle of arrival is, you can see there in the graphic. In this point, with the line of sight wave or line of sight ray is making at the point of 250, around 250, and around 40 in the elevation. So the AOA is gathered in azimuth of 100 degree and 350 degree, and the elevation will be in 30 degree and 80 degree. Based on this AOA and AOD, we can have the normalized angular power profile. So it will show the specular reflection components that it has the dominant rays of those rays. So from those simulations, we can have the point that the AOD or angle of departure spreads out better than AOA, and the relative receive power of scattered rays decreases for larger angles. And then another parameter is from the temporal modeling of the channel. So the phase distribution from -180 to 180 depends on the path length. And then line of sight at azimuth angle of 230.2, if you can see there, in this point with 9.4 nanosecond. So of course, line of sight has the lowest time of arrival. In this simulation, it achieved 1 nanosecond. And then scattered rays propagate around the specular path on a cone shape. So the sailing, because of shorter distance into from the TX to RX. So in between there is sailing, but it's shorter than another reflected rays from the wall or from another material, for example, a door or something. All right, so we're going to the antenna. So today I'm focusing on horn antenna. So the horn antenna is widely employed for high gain application needs, such as satellite communications or in the wireless communication itself. And there are some horn antennas. And in this research was done with pyramidal horn antenna. So this directional terahertz antenna model was mentioned by research in Japan by Professor Toyoda. And then, as you can see there, the directional antenna model for terahertz is, simply, I think it's general for directional antenna. In this research, we have done with comparing to simulated directivity of the antenna, and with the simple model of this. So it is mentioned that the half power beam width of at least 15 degree to 60 degree for wireless communications. And then the main loop also includes side loops for multipath channel. And the antenna pattern of 360 degree covers around the angle of multipath channel. And yeah, the mathematical of the gain you can see there. I think most of you know about it. So it depends on the directivity and the gain itself. According to the antenna model, as shown on the previous slide, there are basically main lobe and side lobe or back lobes in the antenna model. So it's this model is like avoiding the back lobes or side lobes to just simply simulate what will be the directivity without these side lobes into the scenario of these simulations. And there are three types of this antenna horn, right? H plane, A plane, and pyramidal horn itself. What I've mentioned, I want to go to pyramidal horn antenna. This antenna was designed in the frequency of 325 gigahertz to 375 gigahertz with 50 gigahertz bandwidth. So I have three kinds of how to differentiate, how to compare between those three models, I would say, in the antenna before going to having really high directivity or gain. So comparing those three will be like step by step, knowing if we added some form of this antenna, for example, this horn antenna or even lens with lens, it will like what. So let's see from open-ended waveguide. So this open-ended waveguide has dimension of length of only 0.86 millimeter. And yeah, I put with the PEC material. And yeah, as mentioned, I wanna check whether this waveguide elaborate with the horn antenna and how it will be. So with the standard gain horn and scratching down from these formulas. So if we have frequency center, and then the length of what we wanna achieve, then we have to simulate numerically with this parameter. So parameter is this, it seems like X or something. So after numerically simulated, we can achieve this notation or parameter into 2.3. So the varying geometrical parameters are very crucial to define the maximum effective horn parameters. So this point is really crucial to design this horn. And dimension, what I get is like, yeah, as mentioned with the waveguide width and height in the order of millimeter, 0.8 millimeter and 0.4 millimeter. And the horn flare length is only 1.3 millimeters. So I use a waveguide from, it's easily found in the market with VR3, and the material of this antenna, SGH antenna, is with the gold, because I'm comparing those all like PEC or something with the gold, but I achieved the best result was with the gold. So yeah, it's because of the better characteristics, yeah, of course. And then with the standard gain horn, I added with the lens itself, which is designed by based on Fermat's principle. So as you can see there, yeah, the above equation will be like if the you know the material of the lens will help a lot, and the dimension of the lens as well can be pointed these waves from the horn into better directivity. So the lens is designed based on the modified parabolic function as its shape. So what I've done is how to make this from the horn SGH antenna A and B parameters, I mean the height and the width, into this formula. So with a characteristic material of lens, conductivity magnitude of 0.1, and the electric potential of 0.00126, and probability of this with respectively 2.4 and 1. So what I got is the directivity and gain of those three antennas are showing in this picture. So the gain maximum of open-ended waveguide is 8.87 dBi, and then comparing to standard gain horn is almost doubled with the 16, and plus lens will be like more than 6 dBi. And as you can see there, the half-hour beam width for both angles will be smaller if we compare from open-ended waveguide to SGH with lens. So yeah, as mentioned in the previous slides, for how to simplify this model or antenna directivity model. So the maximum gain achieved at the main loop is described by circular symmetrical Gaussian function beam width, as mentioned there in the formula with the Gaussian function for both angles. So the Gaussian beams are adequate to approximate the radiation patterns of realistic antenna types. So in this research, because of, I mean, there was a problem with the time frame. So this antenna design was not done by fabrication, and yeah, it was only with simulation. Okay, then the main lobe of the antenna arrays can be modeled. So I'll go these antenna arrays in the next slides, and it can also be applied for the antenna beamforming. Yeah. So from those simulated radiation patterns of 350 gigahertz antenna, you can see there the waveguide, standard gain horn, and with the lens itself, it's compared to the simplify of with the Gaussian model of the antenna directivity. So the comparison between real simulated and ideal simulated radiation pattern and approximation with the Gaussian model is there. So it's almost nearly close to the realistic simulation from the model itself. And the side lobe only is shown by the real simulated by radiation for the radiation pattern. From there, after having these simulated antennas, so we just fit it into our simulation what we have done before. So before was with the omni to omni. I mean, from the X where X is only omni to omni, but now how to see this impact of the directivity into this scenario. We did it in the same way. So I mean, the material and the room size was the same, but the thing is, we would like to see from 4 points. So this will be impacting, having the impact into the reflection rays, whether this is with the first reflection, second reflection order, and of course the line of sight, and with a non-line of sight area as well. So how it will be. Yeah, I believe that in the inter-satellite links will be only considering the line of sight only. So this is only how to having insight if the channel model of terahertz in room will overviewed by this scenario. So the scenario of this antenna model is with it with the 1.5 degree of half hour beam width to 90 degree half hour beam width. So how this really high gain or directivity into less directivity. What we get is the cumulative distribution function path loss of on varied half power bandwidth for those 4 directivities for receiver 1 till 4 and receiver 3 with non-line of sight. So receiver 3 is non-line of sight. Then the path loss calculated based on this model. So the curve shape is similar if we have with those 4 beam widths, and then path loss is affected by antenna gain only. And then another parameter would be interesting is the RMS delay spread or root mean square of the, this is the manifest of the temporal channel model actually. So this is done by RMS with this formula based on the previous what I mentioned of the channel model. And we can see that extremely low RDS or much less than 1 nanosecond is necessary to avoid the intrasymbol interference. So in this in-room communication, yeah. And then the lower RDS, the smaller half-hour beamwidth. Yeah. All right. So after having the antenna design into a simulated indoor channel, and now how to see within this antenna misalignment, how to simulate this antenna misalignment for those scenarios. So the antenna misalignment usually occurs due to antenna pointing and then a small failure of phase shifters. This is in the hardware point of view, and then mistakes on angle of arrival and departure estimator. So this goes to smart antennas algorithm. So the AOA and AOD will be the important informations or parameters for having the algorithm of, for example, beamforming. So as you can see there, if the, yeah, imagine it, this RX and TX antenna are with the satellites, within the satellites. So if ISL is happening between those two satellites, for example, this will be not, this must be aligned with the threshold of, for example, how many degree of half-hour beamwidth or something. There we can simulate, of course, with the channel model as well. So the antenna and random misalignment, after simulated this those antenna design, so the Gaussian PDF of misalignment angles in azimuth and elevation planes will be like this, and we achieve the gain versus the deviation of misalignment. So we put a range of the deviation of this misalignment degree from 0 to 40 degree, and how the gain impact to this standard deviation. Yeah, we can get that the smaller half-hour beamwidth, or with a higher gain, the higher sensitivity against misalignment with lower mispointing tolerance. So those four half-hour beamwidth, what we have on the previous slide, from 1.5 degree to 90 degree is there. So this is the important point, that from the random misalignment, the directional antennas are employed for both TX and RX antennas in order to achieve the maximum antenna gain and lowest path loss of the system. So this one is how to see the half-hour beamwidth from both angles in the TX and RX and with the path loss. We can achieve that the effective path loss at RX1 with the loss condition with a different half-hour beam width and misalignment angle with a within the 3 degree into 30 degree respectively for this. So this tilted beam, which is not matched to the wanted direction, in turn decreases the link quality. And the symmetric assumption of half-hour beam width X is equal to Rx. So it's, this is considered as for only simplicity purpose. And then the simulation is carried out in the range of misalignment between 0 degree to 60 degree with the steps of 1 degree for about around 3,700 realization values of misalignment for each angle of the X and Rx. What we get is this is related to the K factor of half-hour beam width values. The K factor values are averagely achieved to 1.6729, while these the real value of each misalignment deviation of 3 degree till 30 degree is respectively 1.6 to 1.7. So averagely we get the K values of 1.679. Then the lowest average path loss can be achieved if the half-hour beam width of TX and RX antenna is approximately employed the value of 1.67, as we get from the average values. So it will have a half-hour beam width optimum from the K values multiplied by the standard deviation of misalignment. Then the beam steering method can overcome this problem. So, but still, there will be some misalignments due to hardware algorithm or pointing errors or something. And then we're going to terahertz array. As most of you knows about antenna array. So the array factor must be defined at the beginning for this purpose. So the array factor of linear array is there with the 16 element or 4 elements of array. So we can see the comparison of those 4 with a different type of array and elements. Array with a separated distance between antenna element is within lambda over 3 in the frequency of 350 gigahertz. We have done all the frequency standard frequency of 350. So in order to avoid getting loops, the separation element should be less than lambda over 2, half lambda. So radiation pattern what I showed there is based on the array factor to element factor. And then directional antenna array is done by this formula. So the antenna factor will be from this formulas with planar array of m to n elements dimension with uniform amplitude array. We wanna we would like to see whether these elements is optimally for, especially for indoor room communication with how many elements or something as minimum requirements for this communication system. So simulation of this antenna design was done with 4 elements for antenna horns. So from the previous antenna horn, then simply make it into this antenna array. So the 4 antenna elements have a port each for each those 4 ports. So belongs to multi-port array technique. And then with the same waveguide VR3 used in this SGH antenna as previous slides. And then the spacing array is with this 1.9 millimeter that fits best to the result actually. Even though the grading lobes, what I mentioned is must or should be less than half lambda. And we can achieve this radiation pattern with a gain of the target angle can be set maximum at angle 14 degree, even if it has been set to 30 degree. So below these values, the total array gain is lower than 20 dBi. So it means that the terahertz band in especially in indoor room communication or the short range communication, terahertz communication is unable to build the communications if the gain, the total gain lower than 20 dB. What I can show you is the multipath channel for directional antenna array. So previously, with only simple one antenna, single antenna, and how will be with this antenna array with the same antenna design. So it is with standard gain horn antenna. So in indoor channel scenario, the multipath components come from a few clusters which are composed by scattered rays in each cluster according to as mentioned Saleh-Valens model. And DOA and AOA are very important to construct the covariance matrix. So this information is going to construct the covariance matrix for beamforming purpose. And the AOA estimation, which is obtained from the phase array antenna and the difference of phases among the received signals at each element of antenna array are mapped into the direction of incident. So this is the multipath channel. If it is specular or not specular array, will be it will be simulated there. So this is the same scenario, but with a phase array. After having the antenna array, then going to power splitter or phase shifter to baseband and to the signal baseband. And this AOA estimation is more accurate in order to calculate the received signal strength in the phase array antenna. And the direction of arrival or angle of arrival information. Yeah, as mentioned, this is very important. For beam steering approaches in terms of algorithms, tubular domains, purely analog, or with a hybrid beam steering. From those beamforming scenarios, it is good to mention that there are some algorithms or methods to build this beamforming. For example, this conventional or maximum likelihood, subspace-based, and integrated techniques. The Capons method belongs to a conventional algorithm. So this DOA in all possible directions and will route the highest output power. So this simulation is based on Capons method. The simulation is carried out at the same frequency with the 350 gigahertz with elements of 16 to 16 elements phase array antenna. And I use the uniform planar or rectangular array with 4 outputs to RF chains at both the X and X side. And we achieve this hybrid beamforming from Capons method with reasonable SNR, which is needed to establish the communication link in the context of large array purpose. So the spectral efficiency is there with versus the SNR. So the spectral efficiency, of course, it indicates the number of bit rates which can be transmitted in the given bandwidth. So based on the requirements of short range communication, terahertz communications, it is fulfilled from the spectral efficiency point of view and SNR. Yeah, I think it's last slide. I'm really interested to in taking in charge into the next antenna design in maybe in terahertz reflect array antenna. So it's really happening in Europe with this type of antenna, especially for space communication. Good to mention that I think it will be an insight with this terahertz in-room communication to ISL applications and generally for space communication purpose. Yeah, this is not maybe it's not so fit to the purpose, but I think it's helpful to understand from the channel model point of view, for example, or from the antenna point of view and phase array design and something. Yeah, I know this gain antenna for satellite purpose will be much higher in the order of maybe more than 50 dB. That's why this is the challenge to develop more and more because the nanosatellite will be with a small size of spacecraft with really a big challenge to put this antenna, phase array antenna to on the body. So I believe in the future will be done with this antenna design. Yeah, I think Pak Arifin, that's the last slide from me. Thank you for the attention. Maybe you have guys have questions or something, or have to be discussed further.
Yeah, thank you, Mas Dwi Cahyono. It's really exciting to hear and to watch your presentations. bit something in the future, in the futuristic type of presentation, because you are doing research in the 350 gigahertz, which is another level of technology. So I think we will be limited by time. By 12 o'clock, we have to be finished. But maybe there are some questions from the floor. Please do so by putting at the chat box. You may wish to post any question. For the moment, while we are waiting for such a questions, I just would like to have some kind of clarification. What is the status? What is the status of the electronics? If you are doing more in the RF modelings and so on, and in such frequency, but at the same time we are also to say anything about the amplifiers, about the other what you call it, electronic RF part of the chain and so on and so forth, filters and all that. What is the status of such kind of technology actually?
Yeah. For your information, that this research was conducted in Duisburg-Essen laboratory. So it was with the beyond 300 gigahertz is still in the developing. I mean, in the RF point of view, in that university is still in the development, but in Germany, especially, there are, I would say, 2 or 3 universities with a specialization on this RF development. So the status is clearly now, I think it's already fully developed by those universities. So yeah, as I mentioned, there is a gap with the amplifier point of view in this terahertz band, and beyond in between 300 to 1000 gigahertz, especially. So, but we are going deeply there, especially in RF. But those problem, I think it's already yeah, more or less solved by them actually, Arifin. So the status itself now in from the simulation to realistic model. So they have done with kind of more than 50 meter communications, and yeah, of course, this RF is good, so it will be not a problem at all. I mean, within this range of distance, yeah. But the longer or with the high power, it will be still the challenge. I don't know if in other countries, I think in Japan or China will be like maybe more advanced regarding this RF development.
Thank you. Thank you, Mas. Another question would be, you mentioned that there will be more or less a match between the room simulation that you are doing with the with the inter-satellite links. With the inter-satellite links,
Yes.
this must be related with the cleanness, if you like, from the deterioration point of view due to many of physical happening. I do not know, since maybe there will be less atmosphere there, and I don't know what about any other physical phenomena. What do you think? What do you think actually to use such a frequency in the future for the purpose of satellite communication, for surfing Earth, for surfing the user and Earth, not planetary? So what do you think? What do you think?
Yeah, this is interesting actually, in this frequency band and related to satellite communication. So in this higher frequency, as I mentioned, this will be like hybrid scenario. Yeah. So, and for example, yeah, from the geo satellites to LEO and then ground station on the Earth. This can be happen if we put, for example, this ground station into the low or the lowest absorb molecular vapor water. I mean, in the dry conditions with the dry areas or something. So it will happen this scenario with terahertz link. But if you want to specify into Indonesia, for example, this really difficult to implement it. So I would say maybe I have some papers or researches that I've read before regarding these links between Earth to satellite with terahertz band. So yeah, this is still a challenge, but but if we have this gap, and for example, how to put this ground station or something, or even having more amplifier within the gap of terahertz band, as I mentioned before. So I think this little bit helpful to implement it. But yeah, again, from my point of view, I think it will better to just combine it with the hybrid link communications. So yeah, for example, with ISL or KO to LEO with terahertz link, and then from LEO to ground station to Earth with KA band or KU band. That's not a problem at all, I think.
Oh, that should be very, very interesting if you are talking about hybrid type
Yes.
of network solution. For example, we could have been also talking about the use of hubs, isn't it? Which is at the altitude of 20 kilometers, by which the link between hubs to say, for example, satellite using terahertz could have been rather possible as compared to directly to the ground, of course. But maybe this is something we should explore in the future. 1 minute, can I ask you one more? This is in accordance with the stability. If we were to talk about satellite things, it is inherently needed that the stability of the satellites, in other words, the attitude stability should be as high as required. So in this case, do you think using this terahertz technology, there will be more stable satellite will be so required, or what?
In these terahertz, I would say, yeah, if we talk about the nanosatellite spacecraft, with the smaller spacecraft, I mean, the terahertz phase array will be having more of an advantage because of the smaller footprint of the antenna, for example. And then with the phase array, if you're saying with the ADCS, right, with stability control or something, it may more stable due to this phase array scenarios. So that's why this beam alignment is getting better than FSO. So this is not strictly as FSO, but if we can do or design this phase array antenna in this nano satellite, will be having more maybe brighter beam alignment. So stability, of course, yeah, of course every satellite has stability control, but because of hardware pointing errors or something can be overcome by this phase array, right? In terahertz, especially.
Okay, Mr. Dwi Cahyono, thank you once again, and I think we should give a big applause to Pak Dwi Cahyono.
Thank you,
and, I would like to pass on the floor to Master Ceremony. Thank you very much, Pak Dwi Cahyono. See you again.
Okay. Thank you very much, Mr. Dwi Cahyono, for the insightful explanation, and for Dr. Arifin for leading the first session of the seminar. I would like to say thank you. And before moving on to the next more informative seminar session, now it is the time for us to have a coffee break for 1 hour from now, which means we will start the second session at 1 p.m. in West Indonesian time. Okay, see you in the next session. You may leave the room and take a rest.
Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya, sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai ketua ABJI juga sangat menyambut positif ya atas Kasifik Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya, untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah, ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital, dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri, untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya, sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai ketua ABJI juga sangat menyambut positif ya atas produk Kasifik Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya, untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah, ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital, dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi gitu ya. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya, sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai Ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya, untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah, ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital, dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi gitu ya. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput visat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital, dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Visat merupakan satu-satunya gitu ya sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput visat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital, dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya, sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya, untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah, ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital, dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi gitu ya. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya, sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya, untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah ke depannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah, ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital. Dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Gitu ya. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya, sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai Ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya, untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah ke depannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah, ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital. Dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Gitu ya. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya dan bekerja sama dengan ASN ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital. Dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya dan bekerja sama dengan ASN ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital, dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet, gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau, gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik, gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik, gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya, gitu ya, sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan Kasifik, munculnya Kasifik, gitu ya, di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN, ya. Saya sebagai ketua ABJI juga sangat menyambut positif, ya, atas produk Kasifik rumput Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita, gitu ya, untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah ke depannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah, ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital. Dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi, gitu ya. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet, gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau, gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik, gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik, gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya, gitu ya, sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan Kasifik, munculnya Kasifik, gitu ya, di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN, ya. Saya sebagai ketua ABJI juga sangat menyambut positif, ya, atas produk Pasifik rumput Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital. Dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Gitu ya. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Pasifik gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan munculnya Pasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Pasifik dan ASN ya. Saya sebagai Ketua ABJI juga sangat menyambut positif ya atas produk Pasifik rumput Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital, dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya dan bekerja sama dengan ASN ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. VSAT merupakan satu-satunya gitu ya sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan Kasifik, munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput VSAT yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital. Dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya dan bekerja sama dengan ASN ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. VSAT merupakan satu-satunya gitu ya sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan Kasifik, munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput VSAT yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital, dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet, gitu ya. Kalau kita lihat Indonesia yang terdiri dari Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet, gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau, gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik, gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik, gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya, gitu ya, sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan Kasifik, munculnya Kasifik, gitu ya, di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN, ya. Saya sebagai ketua ABJI juga sangat menyambut positif, ya, atas produk Kasifik rumput Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita, gitu ya, untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital, dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet, gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau, gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik, gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik, gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan Kasifik, munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput visat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital, dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Visat merupakan satu-satunya gitu ya sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan Kasifik, munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput visat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital, dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet, gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau, gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik, gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik, gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya, gitu ya, sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan munculnya Kasifik, gitu ya, di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN, ya. Saya sebagai Ketua ABJI juga sangat menyambut positif, ya, atas produk Kasifik rumput Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita, gitu ya, untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah ke depannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah, ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital, dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet, gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau, gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik, gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan Cubesat, munculnya Cubesat gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Cubesat dan ASN ya. Saya sebagai ketua ABJI juga sangat menyambut positif ya atas produk Cubesat rumput Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital, dan ini harus melakukan transformasi digital secara cepat dan lebih ya baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Cubesat gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan Cubesat, munculnya Cubesat gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Cubesat dan ASN ya. Saya sebagai ketua ABJI juga sangat menyambut positif ya atas produk Cubesat rumput Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital, dan ini harus melakukan transformasi digital secara cepat dan lebih ya baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya, sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah, ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital, dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya, sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai Ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital. Dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan Kasifik, munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai Ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital, dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan Kasifik, munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital, dan ini harus melakukan transformasi digital secara cepat dan lebih ya baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan Kasifik, munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah ke depannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah, ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital. Dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya, sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan Kasifik, munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai Ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah ke depannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah, ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital. Dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya dan bekerja sama dengan ASN ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput Cubesat yang bekerja sama juga dengan ASN sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya dan bekerja sama dengan ASN ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput Cubesat yang bekerja sama juga dengan ASN sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya, sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. Ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput Cubesat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah kedepannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah, ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital, dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Perkenalkan, saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi juga buat penetrasi internet di Indonesia, ataupun namanya untuk membuka akses di daerah-daerah yang memang sulit sekali dicapai oleh fiber optik gitu ya, ataupun daerah-daerah yang sangat sulit juga dicapai oleh radio link. Cubesat merupakan satu-satunya gitu ya, sebuah teknologi yang bisa kita gunakan untuk mencapai daerah-daerah yang posisinya sangat sulit dicapai oleh dua media tersebut yang tadi. Dengan munculnya Kasifik gitu ya di Indonesia, kita berharap ini juga bisa membantu penetrasi internet di daerah-daerah yang sangat sulit dicapai oleh dua media tersebut. ini kan ada kerjasama antara Kasifik dan ASN ya. Saya sebagai ketua ABJI juga sangat menyambut positif ya atas produk Kasifik rumput visat yang bekerja sama juga dengan ASN, sehingga ini menjadi sebuah solusi buat kita gitu ya untuk mencapai daerah-daerah yang seperti yang susah dicapai oleh dua media tersebut. Yang kita harap adalah ke depannya semua daerah-daerah baik itu desa, kecamatan, kabupaten ini bisa segera bisa koneksi internet. Dengan terbukanya koneksi internet di daerah-daerah, ini juga bisa mengangkat yang namanya ekonomi masyarakat digital di daerah tersebut. Mau tidak mau memang kita harus bisa bertransformasi digital. Dan ini harus melakukan transformasi digital secara cepat dan lebih baik lagi. Saya Jamalul Izzah, Ketua Umum ABJI. ABJI ini adalah Asosiasi Penyelenggara Jasa Internet Indonesia. ABJI sebagai pengolah IP address yang ada di Indonesia, dan ini satu-satunya di Indonesia. Nah, jadi banyak beberapa program ABJI yang memang fokus untuk penetrasi internet yang ada di Indonesia. Nah, yang memang menjadi sebuah PR buat kita bersama, dan ini bukan hanya menjadi sebuah tugas pemerintah dan juga menjadi tugas kita sebagai asosiasi industri untuk bagaimana penetrasi internet ini selalu naik setiap tahunnya. Tantangan yang paling berat memang di kita ini saat ini adalah mengenai infrastruktur internet gitu ya. Kalau kita lihat Indonesia yang terdiri dari pulau-pulau gitu ya, dan juga letak geografis yang cukup menantang, infrastruktur menjadi sebuah concern yang cukup penting buat penetrasi internet Indonesia semakin tahun semakin meningkat. Jadi dengan munculnya Kasifik gitu ya, dan bekerja sama dengan ASN, ini menjadikan sebuah solusi.
Okay, the time shows 2 p.m. West Indonesia time. Now it's the time for us to move on to the second seminar session. Before we start, allow me to introduce our moderators for the second session of today's seminar by reading their profiles. The first one, Mr. Edi Setiawan, is a telecommunication engineer by profession, about 29 years now, including 13 years in Telkom Indonesia, and currently is chairing the Indonesia-ITU concern from Forum or IICF, a non-government, not-for-profit organization that focuses on IT-related matters and issues, which he co-founded in 2013, and also a member of Advisory Board of the Satellite Industry Association of India, or SIA India, and member of Advisory Board of Antariksa Space Global. He also participated in telecommunication consultancy, service on satellite communication system engineering, subsea telecommunication cable system engineering, as well as radio frequency spectrum and ITU regulatory matters for public and private sectors, both in Indonesia and overseas. He has extensive experience on PPP projects with the Indonesian Communication and Informatics Ministry for several USO projects. He holds a master's degree on satellite communication engineering from ENSAA/ISAE SUPAERO, Toulouse, France, since 1919. Okay. Good afternoon, Mr. Eddie.
Yes, good afternoon, Mas Kinan, Mr. Kinan, our
Yes.
MC.
It's my pleasure to welcome you today, and thank you for having us here, Mr. Eddie.
Okay, good. Yes, I'm ready to be the MC of this afternoon session.
Okay, thank you very much. And before we start, allow me to introduce our next moderator. Dr. Agnes Irwanti is a professional consultant that also involved as entrepreneur in field of information and communication technology. She holds a PhD in strategic management from IPB University. Dr. Agnes is active in professional organizations that have a positive impact in community, namely IICF and IEEE. Dr. Agnes Irwanti was recognized by IEEE Region 10 as one of the most inspiring women in engineering in the Asia Pacific on 2011. Frequently, she was appointed by Indonesia government as Indonesia delegation to attend international conferences and also invited as speaker and lecturer. She was an expert reviewer in She Will Innovate competition by Asoka, Changemaker, and Intel in 2012, jury on Youth Endeavors for Social Innovation Using Sustainable Technology 2021 to 2022. She is the authors of several scientific books and articles. Dr. Agnes is passionate about PPP strategies, intervention strategies, technology transfer, and adoption strategies. Good afternoon, Dr. Agnes.
Hi, Mas Kinan. Good afternoon.
Hello. Okay, it's my pleasure to welcome you today, and thank you very much for having us in this seminar.
It's my pleasure.
Okay, everyone. Without any further delay, I would like to ask our moderators, Mr. Eddie and Dr. Agnes, to enter the room and lead the seminar. Thank you.
Well, thank you, Mas Kinan. Good afternoon, ladies and gentlemen. Allow me to welcome you to this afternoon session. My name is Agnes Irwanti. I'll be your host for these sessions together with Pak Eddie or Mr. Eddie Setiawan. Hello, Pak Eddie.
Hello, hi, nice to meet you, my beautiful partner. Yet
Thank
also
you, Pak Eddie.
Miss Agnes. Okay, go ahead, Miss Agnes. Yes. Okay, sorry, there is some technical problem here a little bit. Yes, this afternoon, I mean, we're going to have sessions which focusing on the sharing of experience in implementing high throughput satellite system. There will be two panelists or two speakers in this afternoon sessions. One is Mr. Aradia from Bhakti, but due to his situation, it seems that the first speaker will be Christian Arturo, the CEO of Pacific. Hi, Christian, are you there? Hello? Is Christian here? Let me check. Can somebody help me to check whether Christian is already in the Zoom room?
It seems Valerie is there. Valerie is the secretary.
Oh, Valerie. Oh, okay.
Yeah.
Well, we are waiting. Maybe we can read Mr. Christian short bio, Pak Eddie.
Okay, so as I said, there is a slight change in the order of who speak first. Then it will be Christian from Pacific will be speaking first, and then followed by Mr. Aradia from Bhakti. As we know that this morning we spent about 3 hours listening and discussing on very technical matters, very scientific, very engineering. But this afternoon session, we are going to talk or to discuss more on the field experience of the implementation of high throughput satellite system. So without further ado, I will read the biodata of Christian Arturo. Let me read his biodata. Mr. Christian is founder and the CEO of Pacific Broadband Satellite Group right now. Christian has 26 years of experience in the satellite industry, where he previously held senior position in engineering and business development. In 2013, Christian founded Pacific, a new generation broadband satellite operator, bringing affordable, high-speed, and highly accessible internet to Southeast Asia and the Pacific. The Pacific 1 satellite, built by Boeing, was launched in space in December 2019 and is currently delivering its high-quality satellite internet services in more than 20 Asia-Pacific countries. Christian holds a master's in electromechanical engineering from University of Brussels, Belgium, a master's in fluid dynamics from the Von Karman Institute, Belgium, and an MBA from INSEAD Business School. Well, I think that concludes the presentation of short bio of Christian Paturo. So right now, I think it's time for Christian to present your materials, your presentations, and after that we follow it up with discussions. Okay. So Christian, are you ready? Let me check. MC, could you confirm about this?
Okay, I will check the room first.
Yes, thank you. Yeah, sorry about this slight changes on the order of the presenter because Mr. Radia has a slight technical problem, so he will be the second presenter. So, Ms. Agnes, do you have something to say about this?
Yeah, I think that we are very lucky today because we have an incredible speaker, Pak Edi. We have Mr. Aradea from Indonesia Telecommunication Accessibility Agency of the Ministry of Communications and Information Technology of Indonesia. And I think it is, we will get many insights from Pak Aradea also before we heard about Pak Christian sharing session or presentation, Pak Edi.
Okay. Yes, I think it will be a very interesting session because we're not only talking about the very technical matters, but also how to implement high throughput satellite. But it's not nano high throughput satellite. It's a big big high throughput satellite system because Pacific has put or has operated or is operating Pacific 1, which is a GSO satellite, and Bhakti is going to operate its Satria 1 satellite, which is also a high throughput satellite, sometimes next year. So yes, we're still waiting for Christian to show up.
Yeah, I have checked. Incidentally, I have checked the secretary of Christian. It seems now she is after him. So hopefully there will be
okay.
There will be some result. By the way, maybe in waiting for Christian, perhaps we could discuss a little bit what is actually the HTS, something like that, so that people maybe not all of them, of course, are specialists in this regard. So perhaps Pak Edi Setiawan and Bu Agnes and perhaps somebody else could, talk freely about sorry, there is what you call it, an answer from Valerie mentioning this moment. Hi, Arifin, I am contacting Christian now. We'll let you know if he can join early or not. Yeah. Okay. So But Eddie, maybe I could introduce, if I may. The HTS is representing kind of technology disruption at the moment, because in the past, if we are talking quote unquote what you call it, traditional satellite, if you like, the capacity is only maybe limited to, say, for example, 3 to 4 gigabit per second, maybe. But with this kind of technology, because of, first of all, antenna technology allowing multi-beam operations. So, in other words, it looks like a cellular type of communication. It results in multiplying the capacity, the bandwidth, as much as you like. Of course, it's going to be limited by the physical dimensions of the satellite and the physical dimensions that imposed by the launcher in this case. The moment, at this very moment, a technology could show us that a figure like 1 terabit per second is achievable. It is nothing to do with the traditional capacity, right? Which is on the, say, about between 3 and 4 maybe, okay, 4 gigabit per second. Right now it can achieve up to 1 tera gigabit per second at the moment. So it's quite disruptive in this case. So what do you think, Pak? What do you think, Bu?
Yes, I think, well, my personal opinion, why the HTS is getting more and more momentum or becoming more and more popular is because first there is the driving factors of, for example, the 5G. 5G is really the killer application or the killer technology that drive everything, the networks technology, and then also the system platform to provide a truly broadband solutions. And the satellite or traditional satellite technology cannot cope with that. So that's why this is what we call the high throughput satellite, or in the old days it's called the broadband satellite. It's becoming more and more popular or needed. But of course, the increase of capacity, other than the advance in the, for example, the antenna technology that can provide multi-beam capability, but also it must use the higher frequency, like the Ka band, for example, Pak Arifin. If we go to Ku band, then you will not get that size of capacity. And even today, some HTS HTS manufacturer, they also offer the Q and V band. And V, yes. And maybe it will be happening here in Indonesia in in near future, Q and V band, in order to provide a higher capacity than what we have today. So I think in terms of dollar per megabit per second, yes, through HTS we can lower it down. And nowadays we don't really calculate the price for megabit per second. Sorry, calculate the price for satellite service in the old days, like how much per transponder per year now, but now we're talking about megabit per second. So it's getting more and more closer to the terrestrial pricing system. So I think that's what the really goal of not only satellite but the whole telecommunication network or technology well into the future. And even today, there are many groups are talking about the 6G, where it needs higher and higher capacity with very low latency. Maybe I hope I answer your question. I don't know.
Thank you,
Yeah.
Pak Adi. This is a very nice explanation. Asim, I still have to learn here. And well, there are satellite experts, Pak Arifin and Pak Edi. I want to ask, how is the current development of nano satellites and HTS technology in Indonesia, Pak?
I think Pa Arifin is the best person to respond to that question.
Well, actually not. Actually, this morning we have all learned from Pak Wahyudi, which is the director of Satellite Center of BRIN, I believe, isn't it? And he did mention that actually LAPAN has already started with 3 projects, which is already existing right now. As far as small satellite is concerned, they got already in orbit A1, A2, and A3, isn't it? But sooner, he's going to, LAPAN is going to have A4. But beforehand, he did mention this morning that there is some additional project. I do not know which one. I could not recall myself, but it seems he's trying to say anything about the intermediate, program between A3 and A4, and it's going to be realized by the end of this year, if I'm not wrong. So in any case, LAPAN has already got started with the introductions of the technology, and hopefully they are going to continue in doing so. And especially when he did mention that A4, maybe it's going to be consisting of up to 9, I think, up to 9 small satellite, which will be in low Earth orbit, but with 0 inclination. It means that it's going to be at the equatorial. Okay. In such a case, then there will be. I think this is ingenious type of solution, because for covering the whole Indonesia area, it's not necessarily. It is not necessary to have 100 and perhaps also thousands.
Excuse me.
Yeah, sure.
Excuse me. Sorry,
okay.
Sorry, Pak Arifin, for interrupt. I got a message that Mr. Christian is here, so maybe we can continue our.
Sure. Okay. Yeah.
Okay.
Please.
Okay.
Thank you.
Welcome, Christian.
Thank you, Eddie. Thank you, everybody, for having me today.
Yes, I'm sorry for the switch of the position that you become the first presenter in this afternoon sessions, because Aradia might be coming late due to some technical issues. So if that's okay, actually I already read their short bio to the audience, and so maybe we can just straight go to the presentation of yours, if you don't mind.
Okay, yeah, certainly. Shall I share my slides then?
Yes.
Okay.
Yeah. Okay. You can try.
Okay.
If it
Give me a
works.
second.
No
Give me a
problem.
second to find the presentation.
No problem.
Just a second. Just bear with me. I'm downloading the presentation from Box. Just a second. I'll have it.
Okay. Okay. Take your time. Don't worry. Still problem? Or still downloading?
I'm having now. I'm launching PowerPoint. Just a second.
Okay.
Okay. Can you see my slides?
Yes, very clear.
All right. Thank you very much, everybody, for welcoming me today. I'm just going to give you a quick presentation of how we see the role of high throughput satellites in delivering broadband service in the Asia Pacific region. So our vision is at Pacific is really to enable the businesses and government and communities in rural areas, extra-urban areas, really focusing on outside of cities to provide essentially three things: provide a high quality of broadband, or at least a level of broadband quality that allows people to use seamlessly all the internet application, right? So to us, we define broadband as a service that will allow users to not wait for their YouTube to load, not have interruption when they have a Zoom call. So they don't necessarily need 150 megabit per second, but they need sufficient bandwidth to be able to use those regular internet applications. And they cannot have less than that because there's only one internet. There's not the internet for the rich or for the urban citizen. There's an internet for, say, the less rich and the urban and the rural citizen. There's only one internet, one YouTube, one Zoom, etc. So either you have the quality to use it or you just don't use it. The second part is that the internet needs to be affordable because generally people living in rural areas or enterprise operating in rural areas have less margin, less disposable income. And the last part is access. When you want to provide internet in those regions, you need to make sure that you don't ask them to pay $50,000 to install an antenna, right? So it needs to be something that is affordable, and that is usually an infrastructure that is shared by a community or by several users. So what our vision is really to provide that, and I think this is what we have achieved with our first satellite, and we solve really the endemic lack of affordable broadband in the underserved regions of the world. We provide infrastructure freedom to communities so they don't need to load their village with lots of infrastructure. We want to see really how we can help the world in the future. We're actually preparing to launch more satellites. And because of how fast we can deploy our systems, we really make a quick and lasting difference to people of Southeast Asia and the Pacific at the moment. And we do this so fundamentally that we actually have demonstrated that we can even save lives on a regular basis with the health institution, the clinics, the dispensaries, the hospitals that we connect. At a glance, this is specific today. You see every little dot that you see on the map, and there's a lot of them in Indonesia, of course, is a point of presence, is a Pacific terminal. Each of these points actually serves more than one household. It's not really residential service. What we do is usually serving communities, serving government facilities like schools or hospitals, police stations as well. In Papua New Guinea, we serve a number of courts of justice even that we connect together. So really each point connects approximately 50 people, but we have some of those dots that you see in the Pacific Island that connects even 1,000 people. So we have really, in some of those places, we're connecting an entire island or sometimes an entire city. We use Ka-band. We are the pioneers of Ka-band in the region, and a lot of operators have now followed suit to actually embrace Ka-band as well. I can tell you all that when I decided to found the company and use Ka-band, a lot of people were laughing at us that it would never work in tropical areas in Asia. But I was quite emboldened because I know that Ka-band is used in South America with very similar weather patterns. And so we've demonstrated that the weather has never been an issue if you have the right technology, like adaptive coding modulation, like uplink power control. Like recently, we've introduced a multi-resolution coding or dual gateways. So all these are applications that really help the service cope with heavy rain. And really right now, the weather is really not a problem for Ka-band. So what we're doing now is really expanding, and what our plan is to launch another 6 geostationary satellites before the end of the decade. So this is the overall coverage of Pacific 1. You can see that we go for a very, very large area with a single satellite. I know the discussion of today is very much around LEO satellites, but I can guarantee you that if you want to cover an area of that size and be able to put a lot of bandwidth in that area, you'll need at least 1,000 LEO satellites. Because they are shooting by in the sky, and they are by definition a global system rather than a local system. And the beauty of what we see in geostationary is that it's a local system, and you can actually adjust the amount of bandwidth that you're giving. Like in this map, of course, in Indonesia and Philippines, we put a lot more bandwidth than we put in, say, Micronesia or Northern Mariana Islands, where we put a little bit of bandwidth. But of course, Indonesia and Philippines have received the bulk of our satellite bandwidth, really because of the needs, the population density, and the level of development of your country. So today we have 1 satellite. We want to launch another 6th one in the next 8 years. We are well advanced with the procurement of our 2nd satellite, and even an option on a 3rd satellite. We'll be able to announce that in the next few months. We partner with quite a few local partners in the region in Asia Pacific. So here on the right hand side, you can see the main partners that we have both in Indonesia, but as well as in the Philippines, in the Pacific, in Papua New Guinea. We are a very deep and a long-lasting partner, for instance, with Vodafone across the entire Pacific. We're not serving 39 million people today, but what we think we serve about 1 million users today across our entire network, a bit less than 1 million on a regular basis. But you know when we look at the sphere, the area of influence of all those little dots that you saw on the map, we could actually reach easily 39 million users that are in need for connectivity. So that shows you the size of the market. We could easily deploy another 10, 20 satellites in the same region and still find a market for it. So this is a very, very large need. And my personal view is that it will take a very long time to address the demand that is unaddressed today. So in terms of your country, in terms of Indonesia, you know, there are 204 million internet users. You have 73% of the population that are connected on social media, well connected, but you still have 24,000 villages that are, you know, with limited internet as of March 2022. So it is, of course, a huge effort that is undertaken by the Indonesian government as well as the Indonesian telecommunication players to fill that gap. And as we see it now, it's being filled very quickly. But as satellite operator, we have a deep role to play to roll out the supply at a sufficient rate to address that very deep demand. So if you ask why satellite and why not fiber everywhere? Well, fiber is simply impractical across all these regions. If you were to deploy fiber on a point-to-point network across very vast distances with very low population density, it would cost you at least 10 times more than deploying satellite in these regions. Plus, satellites have become much more affordable when you use the high throughput satellite. You can easily bridge the distances with satellite. The distance is actually inbuilt, it's ingrained into the satellite offer. So there is no distribution. The distribution network is in the satellite. So, you know, of course, the topology of the Southeast Asian archipelagos like Indonesia make the satellite the easiest way to deploy, the fastest way to deploy, and also a solution that will last over a long period of time because it is at the right price point today, I believe. And if you were to deploy fiber in these regions, the fiber bandwidth would be more expensive than what you have on satellite because there would not be enough users to justify that infrastructure. Okay. The great thing with high throughput satellite is today with Pacific One, we have fixed beams that we have 56 fixed beams, but the new satellites that we are considering will be entirely flexible. So we will be able now, this new technology that allows to place capacity at will on the Earth, on the visible Earth from the geostationary orbit. So the geostationary, again, is a great system. It has a higher latency, but you know, I often give Zoom calls to investors or to customers on the satellite itself, and they would not notice that I'm on the geostationary satellite. So in fact, for general usage of internet browsing, YouTube, Zoom calls, yes, there is no need for having 20 milliseconds of latency, unless, of course, if you are a heavy gamer and you want to play first-person shooter games. Yes, of course, you're going to lose if you're on geostationary satellite. But then again, you're still going to lose if you're on a MEO or on a LEO satellite compared to a 4 millisecond fiber. right? So that's always relative. So how low is low enough in terms of latency? So for us, we think we are the right solution for definitely the everyday usage of the internet, which is what our customers want. We use Ka band, so it's in the centimeter wavelength. We are actually planning to be very bold for our future satellite and use the millimeter waves in the Q and V band for gateways in the future. We think that this will add a tremendous amount of spectrum on places like Indonesia, Philippines, other places of Southeast Asia that need a lot of spectrum, and the Ka band itself is not enough just to provide the right amount of spectrum to deliver the bandwidth. So we are actually currently studying the use of Q and V band gateways in Indonesia, in other parts of Southeast Asia, even in South Asia. I believe we will be one of the first ones to deploy this technology. But each gateway with a Q and V band has 12 gigahertz of capacity, which is really unheard of. It's actually twice as much as the maximum you can get from a K band gateway. So our satellite is built by Boeing, nothing really particular. It's a really great, robust satellite. Our choice actually for ourselves is that we're taking risks. It's true, we are bold on the market, but at the same time, our view is that we want to partner with solid, reputable manufacturer, launch vehicle provider, launch service provider. So we're not taking any risk on the technology. We want to make sure that the technology is sound, well proven, and that's why we only buy our satellite from established and world-class manufacturers. These are the different systems, different kind of service that we offer. We healthcare, education, we're really good at that. We do a lot of mobile backhaul, including in Indonesia. Of course, we serve the government. We are also very good with disaster response and relief. We have produced a system that we call the comms box that we can deploy easily in disaster zone during the disaster response zone to accompany airdropped crews that would do disaster response. And so we have a system that opens, that has solar panel and connects to the internet anywhere in the Pacific One coverage in a matter of seconds. So you'd have a hotspot anywhere you are in the coverage, and this can be shipped and deployed and activated at the touch of a button. So we have also a special solution that we have network solution for telcos. We operating, for instance, layer 2 system for some players in Indonesia. We also doing trunking on very large antennas. We have some special government services. We serve some maritime and offshore application. We're connecting a few oil and gas rigs. We're connecting coast guards as well, some police stations that need special system for security. So we do all this. We're extremely flexible and versatile, and I think this is how you respond to a market. You need to do both, fixed system, one size fits all. But if customers ask for specific application or you want you to answer tenders, you need to be flexible as well. So just kind of finishing my my presentation with some application here. You can see that we actually serving Bakti in Indonesia. We have deployed a lot of bandwidth on 2,500, more than 2,500 sites. A lot of it is education, healthcare, general government agencies, and we've been really amazed with that collaboration. We are not serving that contract directly. We're serving it through two partners. One is PT Primacom, and the other one is PT BizData, also known as BigNet. And they have rolled out this network in just 5 months. It was really amazing to see the speed of delivery of that network through the organization of Bakti. it was really truly surprising for us at Pacific that the moment we pushed that button, things got rolled out so quickly in such remote areas. So it was really an amazing feat. We also do a lot of mobile backhaul. You can see here the sites that we connect. So these are satellite dishes that are deployed at the foot of 4G towers in rural areas with our partner TeleGlobal. And we have currently close to 400 of these sites doing 4G mobile backhaul. This is in the Philippines, something similar than what we've done with Bacti, but we do that in the Philippines with the DICT, so Department of Infocom in the Philippines. Very similar deployment, connecting schools, hospitals in the Philippines, but on a smaller scale. But really, I think the Philippines and Indonesia should probably talk to each other to learn some lessons. Certainly the Philippines could learn more in terms of scale and planning from our friends at Bacti. And here I have a little video that I wanted to play. Can you hear the sound?
Saya Vina dari Pacific Authorized Distributor atau yang disebutnya KAD. Dengan menggunakan teknologi yang ditawarkan oleh Pacific, yaitu teknologi Ka-band, mempunyai beberapa banyak kelebihan, yaitu dari kecepatan bandwidth, yang kedua dari bandwidth-nya cukup memadai, yang ketiga untuk dari segi harganya pun terjangkau. ASN juga memberikan respon cepat, komunikatif, ramah, dari segi untuk customer service dan NOC yang selalu ready 24 jam. Untuk pengadaan internet di skala desa adalah keterbatasan pada paket layanan. Dan dari pengguna tersebut atau mitra-mitra tersebut memiliki keterbatasan dalam layanan akses internetnya. Layanan internet ASN banyak kami gunakan di bidang pemerintahan desa-desa ataupun masyarakat-masyarakat desa. Layanan internet ASN lebih dapat menyediakan infrastruktur kepada daerah-daerah yang terpencil, daerah yang dekat dari pegunungan, ataupun daerah-daerah yang tidak dapat mengakses internet, ataupun lokasi yang blank spot. Dari daerah-daerah tersebut, kami dapat menawarkan produk-produk dari Pacific untuk memenuhi kebutuhan desa-desa tersebut.
Nama saya Anatua, saya tinggal di daerah Manokwari, Papua. Pekerjaan saya sebagai wira swasta yang sangat membutuhkan layanan internet. Dengan adanya layanan internet dari ASN dan bekerja sama dengan Pacific, sangat membantu untuk menyebarluaskan usaha saya dan mempromosikan apa yang ada di daerah sini dan membantu rakyat dan masyarakat. Masyarakat di sini bisa menggunakan laptop, handphone, dan bisa berkomunikasi dengan dunia maya atau dunia luar. Semenjak adanya ASN bekerja sama dengan Pacific, bisa menggunakan internet dengan lebih puas, bisa menonton YouTube dan media online, dan mengetahui berita-berita dari luar.
Ora ustawan siba, permintaan otonomi daerah di kabupaten di Anggi boleh, itu bisa terima. Ya, telepon bisa orang dari mana, dari Jawa kah, dari Manokwari kah, telepon itu terima seperti biasa. Kalau di sini juga telepon juga bisa terima. Ada 3, nanti satu di sini, satu di Gunung Ayau, satu di Gunung Andang.
So just a last word, and then on the growing opportunity, we think currently we are serving, we are covering 127 million unconnected people. So that represents a staggering demand. Again, that will take a long time. And with our second satellite, Pacific 2, we will both cover what you see here on the right-hand side, so Indonesia, Philippines, Papua New Guinea, but we will actually go beyond in the mid-blue countries and connect all the way to Afghanistan, Pakistan, And thanks to the flexible technology we will deploy, we will be able to shift capacity almost in a second by second basis. We will be able to, or minute by minute, we will be able to change capacity and adapt to the instantaneous demand of our end users. So we're looking forward to that, and we should make an announcement later this year, hopefully, about the start of construction of Pacific 2 and an option on Pacific 3. And thank you very much for having me.
Thank you very much, Christian. Let's give a big applause to Christian for a very good presentation. Now, I'll let Agnes to ask something to Christian. Go ahead, Agnes.
Okay, thank you so much. Such an excellent presentation. Christian, you mentioned that CACIFIC vision is to enable the business and governments and communities in rural area to provide a high quality of a broadband. This is what we want to know deeply, I think. And we will open the question and answer session, Paidi, and we invite all of participants to raise the question you have by writing it down on the chat box, or you can click the raise hand button. And while we are waiting the questions from participants, allow me to ask a question first. Christian, how do you see and perceive the satellite industry and business as a whole can survive and contribute more to the ever increasing broadband environment competition, including competitions with the fiber optic network? What do you think?
Yeah, well, as I referred to in my presentation, you know, I think that satellite actually has many bright days ahead, because, you know, you can't approach a country telecom environment with just a single technology. There are technologies that are suitable for cities that have a high population density, and that is definitely fiber. Fiber is the ultimate system to connect cities. Where I'm sitting here in Singapore, for instance, the entire country is so small and such a high population density. It makes sense to fiber it up. But if I just go across the causeway here in Malaysia, in southern Malaysia, in Johor, there are many patches of that large land that don't really have population. And there you don't have 4G coverage. You don't even have GPRS coverage. You have actually nothing in some of these plantations. And that's where satellite plays a difference. You know, if, like I said, if you were to put satellite, if you were to put fiber in these regions, there would be no usage of that fiber. The fiber would be empty. And remember that when you put fiber, you need to distribute that fiber. So you need actually at the landing point of fiber, you need to put microwave. And people very often forget that you need to distribute the fiber and actually factor in the total cost of ownership of the fiber, including the fiber, the microwave repeater. So my view is that, you know, satellite has not been sitting on its hands and not evolving or not coming up with new technologies. Quite the opposite. There are amazing technologies coming our ways. Including this software-defined satellite that really provide a lot of bandwidth where it's most needed. And I think, you know, the demand is by far larger than any supply we could offer. So I don't see competition as a problem. I'd like to have more competition because that will serve the market, actually. That will finally allow the users that are in heavy need for connectivity to be served.
Okay. Thank you for your explanation. Here is very hard rain, so I little bit not hear you clearly, actually.
I mean, have you read? Have you read it at your place, Agnes?
Yeah.
Okay.
I can see here that Mr. Arifin Nugroho raised hands. Mr. Arifin Nugroho, can you unmute your Zoom so you can directly ask question to Christian?
Yes, certainly. Bonjour, Christian.
Bonjour.
Yeah. I was surprised when you said that actually, as far as delay time or latency is not a problem for by and large. This is very surprising when we keeps on hearing people and engineers are saying that for the sake of the latency, then there should be a system such as a lower orbit satellites, which unfortunately would have needed so many satellites to be launched, and that makes the system will be very expensive from capital point of view. So what do you think about this kind of thought about short latency and as compared with the what you call it the experience that you have until now?
Well, look, again, I gave a presentation to a potential investor about 3 weeks ago, and I gave my entire presentation. I should have done it today, actually, to show you, but because I have a small satellite dish in my backyard here, so I sometime enable it and then show how it works. But I did that presentation, and the investor was amazed at the end when I actually turned on my camera, turned my computer, and showed in my backyard that the presentation was actually run on the dish. They had no idea. So what I'm going to answer here is that a lot of these companies that are launching, LEO and MEO constellation, they've used latency as, and I worked for a MEO operator before, right? So that in my career, I've worked for a few years in MEO. And of course, when you have that attribute, you want to use this as something that differentiates you. So you want actually to show the world that you are better than others. But in fact, it doesn't change anything. It doesn't change the general usage of the internet, except, yes, the likes of Starlink, they could enable things like self-driving cars, again, having better experience when you are first-person shooter. But how many of our friends in rural Indonesia will need self-driving cars? Not many. How many actually need the internet to do first-person shooter games? I'm sure some of the kids would want that, but this is not the fundamental needs that drive the internet. The fundamental needs, I'm going to tell you what it is. It's a nurse that has a bleeding child in a bed in a dispensary in the middle of West Papua, and who's going to call a doctor in Jakarta to help her, to say, how do I stabilize this kid? And we have had this particular event, right, where our system has actually saved a life. So does latency matter there? I can tell you it doesn't matter at all. What matters is that the hospital was connected, that the system was robust, that when she flipped that switch and she was hoping for the doctor to come online, the system worked. The system was extremely robust and pushed the data, and the doctor was answering. So yes, I know the LEO constellation, they want to show they are better, but I am actually prepared to take the challenge to put a Starlink system next to our system and to show that we can do exactly the same thing at the same time, and that they are not better for everyday usage of the internet.
Thank you.
Is there anything else, Pak Arifin Nugroho? Enough?
For the moment, it's okay.
Okay, thank you. Thank you, Christian. Maybe you have another question, Pak Edi.
Oh, yes, Agnes. I think Christian has explained very detailed about the advantages of the geo high throughput satellite. Maybe my next question is, maybe you have explained in your presentation that what is the market segments in particular in the future for the high throughput satellite, especially the GSO high throughput, sorry, GSO HTS. Go ahead.
Well, I think the high throughput is definitely designed for internet usage. You know, so I think the high throughput is by definition a system that needs a lot of spectrum reuse, frequency reuse, and therefore it has very small beams, right? So the smaller the beam, the more spectrum reuse you can have, and therefore those systems are not designed for television broadcast, for instance. They don't do that very well. They are designed specifically to deliver broadband, unicast broadband to a particular terminal. And I think in the future, perhaps the beams are going to become so small that you could almost have one beam per terminal, or actually one beam per small group of terminal. We are almost there already with Pacific 2, where with Pacific 2, we're looking at about 800 to 1,000 beams actually that we could create with the satellites. It's quite amazing. So really broadband is the right thing, but broadband at large. I think mobile backhaul will remain a very significant source of revenue for HTS operators. It's still broadband, but it's the way you deliver the broadband that will be a bit different via mobile phone. I think 5G will be the next stage or so for HTS. We are not really connecting 5G towers because 5G towers are mainly in cities today. That's the nature of 5G, to actually enhance your spectrum inside cities. But I hope that the 5G protocol will be actually expanded into a protocol for wider beams, so that 4G will evolve into 5G in rural areas as well. Yeah, so the answer is quite simple. I think it's only broadband, and I think the future is great for broadband. The demand is actually increasing every day. The internet is becoming richer and richer. Today, you cannot. I mean, if you use the broadband quality you had at the office or at home 10 years ago, to use YouTube from today, the YouTube of today, you couldn't use it. The internet is becoming so much richer every day. The programmer of all these applications are sitting in cities that have fiber. So actually, we have to deliver more and more bandwidth, and we have to launch more satellites because that's my view, is that's the only way to connect the rural areas and to connect the last 10 or 15% of the Indonesian population.
Okay, thank you, Christian. May I ask another? Oh, sorry. I see someone right on the chat box, Agnes.
Okay,
yeah.
we'll see the question.
So who is going to read the question?
This is the question from Pak Mulyana. The question is, any possibilities to increase capacity for East Indonesia beams?
Yeah, unfortunately, there's so much that we can do with Pacific 1. Our satellite is very, very popular, especially in the eastern part of the country. When I designed Pacific 1, I was heavily involved in the design of the satellite. I really put as much capacity as I could on the eastern part of the country. At the same time, because of the Indonesian regulation, where as a private operator, you're always a little bit concerned about the landing rights of Indonesia, right? So when you put money ahead of time, especially for a satellite that will have fixed beam. This is no longer the case with a Pacific 2, where if we don't get landing rights eventually, well, we'll put the capacity in other markets. But with Pacific 1, I could not. I had my fixed beam. My beams were dedicated to Indonesia, so I had to take a leap of faith. And so we could have put a little bit more bandwidth on Indonesia, but you know, it was essentially because of the concern of the landing rights that we actually limited ourselves, and our investors, they also say, well, don't take too much risk there, because if it takes you years to get landing rights, you may have a problem. So at the moment, we're doing everything we can to increase a little bit of the capacity in Eastern Indonesia. We have uploaded patches on our modems that will allow us to free a little bit of margin that the modem we're keeping in terms of satellite power. So we're operating really at the limit right now. Unfortunately, we are looking at perhaps a small interim satellite in the next 2 years. We are discussing with some manufacturer to launch a small satellite dedicated to Eastern Indonesia that could potentially address that issue. But at the moment, unfortunately, there are physical limitations we have.
Okay, thank you, Christian.
So actually, the main issue is about the regulation, yeah, Christian.
It was, yeah. Already, right now it's physical. There's so much capacity we have put on the satellite, but originally, you know, the main issue that created this was certainly the regulation that, you know, we had to comply with, and we had to limit our risk with the regulation. In hindsight, knowing what I know today, that we actually got an extremely good support from the Indonesian government to actually put our bandwidth over Indonesia because of the need for bandwidth. I would have put more bandwidth, but at the time I didn't know, so we limited the amount of bandwidth and put it elsewhere.
Okay, thank you. Well, I want to ask about the ecosystem, Christian. Is there any issues on the labor shortage or number and skills for the high throughput satellite ground segment deployment? And what are the major challenges on the final aspect, I mean the financial aspect, to support any future high throughput satellites project, especially in Asia Pacific region?
Right. Well, I guess generally the main issue that we have is to find qualified installers and installers that are consistently deploying the system properly. So what we've done, you know, because the moment a VSAT is not pointed properly at the satellite, if it's pointed slightly off, it can consume 3 times more bandwidth from the satellite as a well-pointed satellite, right? So basically the efficiency degrades, and yet because it's a high throughput system, the system is going to push as much bandwidth as it can, and then actually degrade the amount of megahertz that it uses. So what we've done, of course, we've trained our installers throughout Indonesia and throughout other countries. And also we have a system where we regularly check online every week, and we contact our partners to go back to certain sites that are degrading. Sometimes, you know, you have children playing around a VSAT, they throw a football at it, and then it gets off pointed. So we have all kind of things like this. And so we need to go back on site and repoint. So Pacific has developed, we have set up a special department at Pacific. We call that the Pacific Lab. And we have developed 2 prototypes of self-pointing terminals. So it's terminals that are motorized and actually will repoint themselves automatically and install themselves alone as well. So we have 2 prototypes, and we have a lot of interest for these because these are just $150 systems. So they're very, very cheap. A motorized antenna that we can roll out on thousands of sites. So we really definitely want to do this. Now, shifting gear to your second part of your question on how do you finance a geostationary satellite? Well, it's not easy to find investors that are willing to actually learn what a satellite is, how, they're always afraid of the risk of launching the satellite. They need to learn how about the insurance, how the insurance covers the launch, etc. So there's always this fear about the satellite, because the problem with our industry is that every time it's in the news, it's because something bad happened. A rocket has failed, and then everybody watches that, especially those who don't know the industry. And then, it creates actually a lot of bad press. Also, it's in the news sometimes for bankruptcies, especially for these companies that have tried something crazy, some new technology, and then they fail. And it's in the news, and that's never good for raising capital for our industry. Also, the development cycles are very long, right? So you need to buy a satellite today. It's only going to be launched 3 years later and enter into service more than 3 years later. So investors are always a bit concerned about that. But in the end, I guess for Pacific One, I have close to 100 investors, very small ones and some large ones. I've pitched for raising money for Pacific One about 600 times, if I remember well. So I spent my life pitching and trying to raise money. Some markets, some type of investors, like rich people, family offices, offices from very high net worth individual, are responding well to that. We still hoping to get investment from Indonesian investors as well. It would be great for us to have one of our large investors to be from Indonesia. So definitely, it's actually difficult, but at the same time, once you have an investor with you that has gotten its head around the infrastructure nature of the satellite business, usually they stay with you because they understand this is actually a great business to be in. The market is great, the market is very stable, and as we've seen with the COVID pandemic, it's actually a very stable business, much better than investing in transport or in hospitality. It's a market that is stable throughout a pandemic because people need internet just like food, So it's actually once you get beyond the hurdle of launching satellite, investor actually realize that it's a great business to invest in.
Thank you.
Thank you for the explanations.
Yes, I think due to the sort of time, I think we should conclude your time slot by 3:10, and we would like to thank you once again, and let's give a big round of applause to Christian. Thank you.
Thank you very much. Thank you for having me.
Yes, for those who write the question to chat box, we will provide the response later on. I think it's from Pak Satrio, right? Okay. I'm sorry, Pak Satrio. Okay, then the next panelist or the next speaker, Pak Aradia is already in the room. So I will let Agnes to read out Pak Aradia brief biodata. Go ahead. You're still muted, Bu.
Okay, thank you, Pak Edi. Good afternoon, Pak Aradea.
Well, good afternoon, everyone.
Allow me to read your short bio. Mr. Aradea has been actively involved in Indonesia's USO program since 2010, starting in BPPTI, former Indonesia USO Fund Management Office, and Mr. Aradea was thoroughly active in implementing Indonesia USO programs such as Desa Dering. It is a phone facility for villages, district and mobile district internet service center, national internet exchange, and many more. And not only in planning strategies, Pak Aradea also went to almost every USO site in order to supervise the constructions and developments of the facilities and examine the functionality of the facilities. As BPPTI transformed into Bakti, Pak Aredia continues his working in implementing Indonesia-ITU program. His work branches out in every infrastructure project in Bakti. In the past few years, he is focusing on 4G coverage acceleration program, which includes in developing backbone, backhaul, ground segment, and also satellite. And his role in Satria, Indonesia multifunction satellite, is very crucial. He was leading the procurements of Satria project and now an active member of a cooperation between government and business entities Council of Satria. This year, he is also focusing on the hot backup satellite project, a project to establish the backup satellite for Satria 1. And his vision for Bakti to have satellites that fully dedicate to deliver non-commercial service for Indonesian people will soon become fulfilled once Satria is the orbit in 2023. Well, we are so lucky, got a very competent source person. Since we will discuss about high throughput technology implementation in Indonesia with Mr. Aradea. We will directly have a discussion session. And maybe there is a presentation, Pak.
I think for the beginning, I would like to present what is Bakti right now been doing at the.
Tapi aku baru tahu nih Mas Ara. Padahal ternyata Bu Agnes itu pemain lama di satelit, pinter banget.
Oh.
Sorry, there's a leaking on the Zoom. Yeah, I just want to explain a little bit about Bakti, especially in the satellite segment. The business process that we had and the future business process that we going to pursue at the future. So can I begin with the short of presentation?
Sure. Yeah, sure. Please, the time is yours, Pak.
Okay. Sorry, I don't have any Astro right now.
Yes, it's okay.
So, can you see it like this?
Yes.
This is my presentation. Is clear? Okay.
Yes.
Okay. Let me start from the beginning. Let me introduce about Bakti. So, and I've introduced myself first. My name is Aradea. I have a long name actually, Sri Sanggrama Aradea. I'm now the head of satellite division in Bakti. So I've been handling, like Bu Agnes already saying that almost all the infrastructure in Bakti, I've been handling those projects actually. So let me start from very specific about the satellite project in Bakti. So the briefly introduction about Bakti. Bakti is a unit under Communication Informatic Ministry, MCI, who deliver ICT infrastructure in ecosystem to the people in remote area and rural area in Indonesia. So we use the USO fund, 1.25% from the gross revenue from the telco industry to build the infrastructure and to maintain the community of development. So we focusing on building an access, either there's an internet access or mobile backbone and marine cable, right? So we focusing on the remote rural area, border area, isolated area, and underdeveloped region. We can say here this is maybe in an 8 main project that we have right now. The first one, we have the internet access project. So we provide the internet access for the school, clinics, and local government office in the rural area. So we deliver broadband services into the public government premises. And the next one, nearly in the future, we going to have the multifunction satellite, as we call it, Satria-1. This high throughput satellite is going to be deliver 150 gigabyte satellite capacity for the 150,000 public facilities will be connected around Indonesia. So and the other one we have I like to call it the Satria Junior, right? Because the capacity is quite small. It's more smaller than the Satria-1. The mission is to be the hot backup satellite. The capacity is around 88 gigabyte capacity satellite, high throughput capacity satellite. And the mission is to back up the satellite Satria-1. If there are any anomalies on everything malfunction in the Satria-1, then the hot backup satellite is going to be complementary, as we say. So the other one, the next one, the program is the satellite capacity, list capacity. So the list capacity right now, we build lease capacity from the foreign and the local satellite provider. At the beginning, we already saw the Christian for the using Pacific capacity. So we have a lot of capacity from Pacific. It's almost maybe around 5 gigabyte capacity that we using to the Pacific satellite. So that's what only one example for the foreign satellite that we lease right now. So for the 5 project, we have a BTS last mile project. We provide a mobile telecommunication for rural area. And the other one, the next project is Palaparing. Palaparing is going to connect from submarine and land cable to connect 57 district connected with the fiber optic. And for the future, right now we on the track to providing the more capacity through the satellite project. So Kominfo through Bhakti decide to going to procure a Satria 2 project. So this is one of the good news for everyone in the satellite market right now. So we're going to procure around 300 Gbps satellite to improve Satria 1 satellite services. So at the beginning, Satria 1 is only going to produce for 150,000 public facilities. Is only maybe around 1 or 2 Mbps for each premises. I think for time being right now, those kind of capacity is not enough for everyone to do or to use in everywhere in Indonesia. So last and not least, so we have a project for broadband community development. So we're developing community capacity to get benefit from the broadband access. So we already build the infrastructure for the ICT, and right now we quite focusing on the ecosystem. So we all know that right now that we need all the resource that we have to maintain and to roll out the infrastructure out there in Indonesia. So that's why we need to building up the capacity for the resource to do it. So that's why from the ecosystem wise, we need to improve all the people around Indonesia to back up all the infrastructure that we build. Okay, next. So briefly introduction about the Satria project, Satria 1 project. So this is we can see over here, as we had a lot of premises, government premises that we need to be connected. It's around totally almost 150,000 location. So the satellite is expected to be the best solution to providing communication network in Indonesian challenging graphical condition and terrestrial network provision. So in 2019, Kominfo is already declared what is called the new mission of the Kominfo is to bridging the digital divide to cross Indonesia. So at that time we already think that only the solution from satellite that can bring the efficiency and the fastest deployment that we can bring to the people around Indonesia, because the geographical and a lot of island in Indonesia, right? So Satria 1 is going to be concession period 15 years. This is a PPP scheme project, public-private partnership between Ministry of Informatics and we call it right now the one who win the tender is a PT Satellite Nusantara 3. So the concession is 15 years. So launch plan is going to be launched around 2023, construction period 2020 until 2023, and it's going to be operate plans around 2023. So this is the first satellite PPP project across the world, actually. We'll skip this scheme. So this is the head-ups about the capacity is around 150 gigabytes. So it's using the K-band, and it's going to be manufactured at the Thales Alenia Space right now in France. So it's going to be a part in orbital slot 1146 East. So administration in Indonesia, and the ownership of the operator is PSN. So it's going to be a propulsion, orbit racing, electrical. So the Satria 1 is going to be having 160 spot beams. This is high throughput satellite. The launcher is going to be using the Falcon 9 from SpaceX. So we're going to have 11 gateway around Indonesia, and probably this is the first big high throughput satellite is in the Southeast Asia, hopefully. And meanwhile, for the milestone right now, so the signing of the agreement is already been signed in Q1 2019, and this is I'm gonna skip this. And the latest one is financial close in Q1 2020, and construction right now we in the spot of construction, and hopefully the operation and maintenance is going to be on schedule around Q4 2023. So that's a little bit about Satria 1 project. And next one, I want to explain about the next project, satellite project. So this is the hot backup satellite project of review. So the provider is going to be fulfill all the project right now is, we call it Kemitra Nusantara Jaya, KNG, and the capex is around 5.2 billion or 5.2 trillion rupiah, and the opex is for years is 475 billion rupiah. Satellite is definitely high throughput satellite. So the ownership is Cubesat. Project delivery method is build, transfer, and operate, or BTO. So the operator is going to build the satellite, then transfer the asset to the Bhakti, and then the finalized and operate by them too. And the ownership by Bhakti based on 80 gigabyte satellite service capacity, 50% ownership with the main backup satellite which are the equivalent of the one complete set of spacecraft control center, name backup SCC, and 100% ownership IP processing hub. So, okay, and hopefully the operation date is around October 2023. This satellite is hopefully is going to be more faster. The deployment of this satellite is faster than Satria 1, so it's going to be deployed almost 2 months earlier from the Satria 1 project. So the construction is between March 2020 and March 2023. So the satellite is going to be launched around April 2023. For the specification, it is the same with the Satria 1. We're using the Ka-band satellite, but the satellite manufacturer is from Boeing, from the United States. So this is going to be parked around the orbital slot 113 East Indonesia orbital slot. Its propulsion is going to be hybrid propulsion. So we're going to have 7 gateways. So the 7 gateways is going to be 4 of them is going to be the same place with the Satria 1 gateway. So it's going to be having the 86 spot beams. Launch definitely is going to be the SpaceX, but because it's only one run in everywhere right now, and the capacity is 80 gigabytes capacity. Okay, so this is briefly about the Hot Backup Satellite Project Gateway. The Hot Backup Gateway project is going to be 7 Earth stations located in several cities in Indonesia, including Banda Aceh, Bengkulu, Cikarang, Gresik, Banjarmasin, Tarakan, and Kupang. The Hot Backup Satellite Project will have 2 sets of satellite control SCC, primary SCC and the backup SCC. This primary SCC located in Cikarang, Bekasi, West Java, whereas the antenna RF subsystem are located in Banda Aceh. The SCC backup is located in Banjarmasin with the antenna and RF subsystem located in Kupang. Okay, so this is the milestone. So we already passed the feasibility study, preparation of planning, we already passed it. Signing the Hot Backup Project Satellite Agreement is in Q 2022. So Q2 and 2022 until Q3 2023 is the construction period, and hopefully in beginning of Q4 2023 we're going to have the capacity from the Hot Backup satellite. Okay, so I will summarize some from the Bhakti point of view. The Ministry of Communication and Information seeks to build national digital fundamental in more structured and massive manner. This is reflected in the 3 strategic objectives of the Ministry of Communication and Information. So this the Satria project is reflected in the first objective of the Ministry of Communication. Is to improve and provision equitable distribution and equity ICT infrastructure through Indonesia. So the goals of MCI strategic goals 2020 and to 2024 on satellite project. So we built the Satria Project 1 Hot Backup Satellite, Satria 2 project 300 Gbps, and the milestone for right now we're still seeking for the total of the capacity through Indonesia is around 1 terabyte. So this is about the summarize about what Bhakti already doing and the future program that Bhakti going to be implemented in the future. So thank you, Pak.
Thank you for the. Yes. Okay, Pak Edi, go ahead. Okay.
First.
Thank you for the excellent presentation, Pak Aradea, which certainly give us insights. And we can see in Pak Aradea presentation that to overcome the digital divide, Bhakti is concerned with infrastructure development focus in a rural area.
Mhm.
And one of them is Satria 1, using high throughput satellite communication technology. Very excellent.
That's correct.
Yeah. Well, now we will open the question and answer. We invite all of the participants here to raise the question you have by writing it down on the chat box, or you can click the raise hand button. And while we waiting for the question from participant, Pak Edi, you get the first chance to ask the question.
This is the question from my master. Okay, Pak.
Not really, not really. Yes, I just happened to support or to work with Pak Radia during the early phase of the project anyway. Okay, Pak Radia, thanks a lot for your presentations. I have a question first about the decisions to choose the HTS as the solution for Satria 1. Actually, Bhakti could use the non-HTS, right? But I just want to know why Bhakti finally, or Bhakti Kominfo finally chose the HTS as the solution for Satria 1. And secondly, will the next Satria 2 or maybe Satria 3, I've heard about this before, will also be based on the HTS technology?
Okay, so the question is about the decision of choosing the STS satellite.
Yes.
Okay, so back then in 2018, we have a feasibility study about the demand that we need to be covered by the satellite. So it's approximately, we have a demand around 150,000 public premises. So at that time, we have two options that we going to deliver in the one GSO satellite by using the K-band. So that's the K-band is only visible. I think only the visible frequency that we can deliver to provide 150 gigabytes capacity satellite that day. So the decision is already been made that we going to using the the GSO satellite, and for the question about whether we're going to using the non-GSO solution at the future, it's still on the table actually, but as we know right now, the non-GSO satellite solution is not that cheap. It's quite expensive if we're talking about the constellation of the non-GSO satellite. Based on our study right now, we need almost around 6 active. If we want to build a constellation, maybe around 10 small satellite. If we're launching in the LEO constellation. So for those kind of solution, we still searching for the maybe future partner, because as we know, the LEO constellation that everybody, it says like a hype right now. Everybody talking about it, and Starlink and Elon Musk make it more happening, and it's making it clear that the future for the satellite maybe is going to be strict over there. But so back again to our initiate project right now, we still consider the GEO solution is the best for now. While we're waiting for the solution around non-GEO satellite is going to be proven, and then more economic cost that and a lot of benefit that they need to show to us, to everyone in the satellite market, right?
Okay, thank you, Pak Radia. Well, actually, I asked about the next Satria 2, as you explained. Will Bhakti still consider HTS as the solutions, technology solutions?
About the Satria 2, right? So the Satria 2 is definitely is going to be using the STS solution, because the main goal for the Satria 2 is to adding capacity for the Satria 1 and the hot backup satellite. So is the only purpose for Satria 2 is providing the capacity for the same public premises, Pak.
Okay.
So the demand is still 150,000, but the capacity is add-on, Pak.
Also, Satria 2 will add up a better throughput than
yes, Pak.
Use Satria 1 and HPS. Okay. Thank you, Pak Ara. Go ahead, Agnes. Do you have some questions to Pak Ara? Go ahead.
Okay, thank you. Excellent explanation, Pak Ara. Thank you so much. Actually, in my opinions, I will ask you about why Bhakti use satellite technology that you mentioned before that it is very expensive, but later you explained that Bhakti have make like feasibility study about the demands. So I really understand now. And I have one question, Pak. With so much new capacity going into orbit, what impact do you expect on the available inventory for traditional fixed satellite services, I mean, and the terrestrial network that has been deployed? Is there any potential for being over capacity or underutilized for the overall capacity? I think this is the big issue now in Bhakti. Thank you.
Yeah, so I think at the beginning we only understand that a lot of capacity right now for the non-STS satellite around Indonesia right now. So we try to make it more. We need to underline what Bhakti and Kominfo did. This is not how to disrupt the market. We're not doing this to disrupt the market. We're doing this to deliver the services, internet services, to the people around Indonesia, through the public services, government services. So that needs to be underlined. If we're talking about the overall capacity beside the STS solution in the future, at the beginning, we only serving the government premises, right? If we're talking about the school, so we only serving the student. How about the people around the school? How about the villagers? How about everyone else? So this is the time that satellite industry or satellite operator around Indonesia need to be filling the gap. So I think right now what Bhakti and Kominfo doing right now is just to be a catalyst for a broadband and digital divide in the future. So I think the market is still there, and I always remember what Terry Blizzard in Intelsat saying that when the God create Indonesia, he always loved satellite operator, right? So that's one thing that always stick in my head right now. Whenever I procure or maybe planning for a new satellite. That's all, Agnes. Thank you.
Thank you, Pak Aradea.
Answer, Pak Aradea.
So long live satellite Indonesia.
It's by default, Pak.
By default, yeah. Okay. Anything else you want to ask, Agnes, to Pak Aradea?
Enough from me, Pak Edi. Maybe I see here there is Pak Satrio. Pak Satrio, do you have any question for Pak Aradea?
At the moment, enough, Bu Agnes. Thank you.
Okay.
If not, then I have one question to Paradia, but this is related to the future in terms of, nowadays a lot of people talking about the 5G, and also 6G is coming up.
Yes.
Just a few days, last week, I attended the workshop on the 6G, or in the ITU we call it IMT 2030 and beyond. So there are a lot of hopes about the future applications, such as the hologram communication and so forth. So how do you perceive as Bhakti about this trend, Paradia, in particular on using the satellite technology with the HTS technology?
Yes, Pak. I think the question is a little bit, I'm sorry for my words, a little bit overrated for Bhakti, Pak. At the beginning from my presentation, Bhakti is focusing on the rural area, Pak. As we know right now, 4G, 5G, 6G, the new protocols that have been around right now is still a new one, Pak. So we still have around almost 30% of our people in Indonesia, even they don't have any good or standard internet access around the Indonesia. But so if you're talking about where is a Bhakti part in the future, especially in the satellite program to providing 5G or maybe a 6G, we still just wait and see about that. And after all, with the new technology from the high throughput satellite, by using the SDS, software-defined satellite or software-defined hardware, we still waiting for those kind of technology to be implemented in some area. So I think right now, if you're asking me about the 5G at the future, right now, and this very moment, but we're still developing 4G, but around in rural area right now. So let's talk about the 5G maybe around 2 years or 3 years in the future. But thank you.
Okay, thank you. Thank you for your response. So is there any questions from the participants? Arifin, perhaps you want to ask something to Paradia? Agnes, do you have any more questions?
Pak.
Okay. I heard some.
Pak Edi, allow me this. Yeah, allow me for this opportunity on behalf of IEEE Indonesia. Would like to thank you, Pak Aradia, for having delivered excellent presentation. Matur nuwun, Pak.
Suwun, Pak.
Okay, that's all, Pak Arifin. Because if Pak Arifin questions, then we need a whiteboard to explain in mathematical formula, perhaps. Okay. So if there is no more questions, then we can conclude the session of Paradia. Okay. So once again, we would like to thank you, Paradia, for your excellent presentations, and it is very clear that to all of us the reasons why Bhakti.Info choose HTS platform for its Satria 1 and then next Satria 2 and so on. So once again, let's give a big applause to Paradia.
Thank you, Paradia.
Thank you very much for this opportunity, Pak.
Okay, thank you.
Well, Pak Edi, and for now, Mr. Satrio will deliver the summary of all of the session in this webinar.
Yes.
Okay.
So let's give it to MC to read the Pak Satrio biodata. MC, go ahead. Thank you.
Okay. Thank you very much, Mr. Eddie and Dr. Agnes for your time, and Mr. Aradia for the explanation. And so before we continue, allow me to introduce our next speaker for the topic for today's seminar by reading his profile. I'm so sorry. There's a technical problems with my device. Okay, I'm so sorry, for the problem of my device. Let me continue. Before we continue, allow me to introduce our speakers for the topic for today's seminar by reading his profile. Satrio Darmanto is an ICT professional with more than 25 years of experience and expertise in the ICT industry. He has a master's degree in RF material science and bachelor's degree in electronics and communication engineering. He also has non-formal education and training in the field of ICT, management, and business. More than 20 universities in Indonesia had invited him as a guest star lecturer to provide sharing session in the field of ICT, digital business, entrepreneurship, strategy management, and knowledge management. International institutions such as IEEE, CCOP, CISB, BAA, ABU, and AIBD had also invited him as a speaker in their international forums. He also contributed to the transfer of knowledge and implementation of satellite communication technology to Indonesia Police Headquarters, implemented in 32 regional police offices, and also to 12 TV broadcasters and 3 telco operators. Satrio Darmanto has written 5 books in ICT. He has also written many articles that have been published in IEEE Digital Explorer, indexed by Scopus, as well as published articles in several newspapers and magazines in Indonesia. Currently, Satrio Darmanto is a member of IICF and advisory board of IEEE Indonesia section, a senior member of IEEE, and actively contributes to IEEE Communication Society, IEEE Broadcasting Society, and IEEE Computer Society. He was the IEEE R10 Asia Pacific Industry Relation Committee, IEEE Communication Society Chapter Chair, and IEEE Indonesia Section Chair. Okay. Good afternoon.
Good afternoon,
Good
Kinan.
afternoon, Mr. Satrio.
Yeah,
I'm so
thank you
sorry
very
there's a
much.
problem with my device. I will fix it first. So I cannot turn on my camera, but I will turn on it as soon as possible. So you can see my face and we can talk face to face.
And thank you very much for having me today. And it's really my pleasure to speak with you, Mr. Satrio.
Thank you.
Thank you. Okay, you can start the topic, Mr.
Okay, Kenan. Thank you very much. And I also thank you to Pak Arifin and moderator Mr. Edi Setiawan and Dr. Agnes Irwanti. Assalamualaikum warahmatullahi wabarakatuh. First and foremost, I would like to say thank you and express my appreciation to all of the distinguished speakers and participants in for your valuable contribution on this occasion of our national web seminar on nano high throughput satellite technologies, challenges and prospects. My deepest gratitude goes to all who attend and participate in this webinar and help to make it such a successful webinar event. In this closing session, I would like to summarize some point of discussion which we have done in the morning and afternoon sessions. In this opening remark, Dr. Arifin Nugroho of Telkomsat highlighted that nano satellite has many benefits to improve the benefit of the internet application, especially in remote areas with a fast and affordable solution. There are some research and development in many universities and also business industries to improve the performance of nano satellites implementation. Keynote speaker Dr. Engineer Wahyudi Hasbi, Chief of Satellite Technology Center, National Research and Innovation Agency, highlighted that nano low Earth orbit constellation satellite for narrowband communication have several missions, such as supporting disaster early warning, maritime surveillance, machine-to-machine, and Internet of Things communication. However, BRIN has seriously done and continues sustainable research, especially under the Nusantara constellation roadmap, with high-profile human resource and standardized test and research facility that will support the development of the satellite industry, startup, space in Indonesia, and international cooperation from business and technology perspectives. For business model, BRIN proposed a joint development, public-private partnership, or PPP, to improve the participation of Indonesian players, especially from the private sectors. BRIN also makes the preparation of HR, the TUT programs, satellite research, development of data processing, including algorithm, validation, and correction. BRIN also provides support to satellite frequency filling and coordination. Furthermore, BRIN also provides policy support to get easy investment, tax deduction, Ministry of Transportation, and other Indonesian ministry support. And moreover, BRIN also made a preparation for the development of rocket and spaceport technology. Very interesting and insightful presentation from Dr. Wahyudi Hasbi this morning. The second speaker, Mr. Filial Fahri, MT from Electrical Engineering Department, Trisakti University, just shared us about adaptive resource allocation for multi-beam satellite. Mr. Filial presents very insightful research findings based on his simulation research. He found that there are some differences between monobeam and multi-beam satellite technology. However, the multi-beam, or well known as HTS satellite, has a wider capacity, but as a consequence, it has some challenge, especially the gap between demand and supply, and low efficiency due to the traffic being asymmetrical. There are some research approaches to improve the efficiencies. Mr. Filial proposed a strategic approach based on adaptive resource allocation called adaptive multi-beam satellite, with a microcell or sub-beam activation to improve the user adaptive and more optimal sub-beam or spot beam capacity. Based on the simulation and research finding, the improvement of efficiency will up to 87%. Very insightful sharing in the session. There are an interesting discussion about how to improve this research and also for further work from the for the research. The third speaker, Mr. Dwi Cahyono, ST, MSc from University of Duisburg, Essen, IKKI Technology, Mercedes-Benz Technology, is just provided insightful shares regarding antenna design and misalignment for nano HTS. Starting with the question, why terahertz is important in communication? Terahertz would be a promise in the future, as well as their many challenges, especially implementing terahertz communication in space communication. Terahertz communication is targeted to be implemented in many sectors, such as data center networks, intra-device communication, wireless local area network, vehicle-to-vehicle communication, and some other implementation sectors. And however, for inter-satellite link communication, the main consideration is the very big attenuation speed. Also, terahertz signal is highly affected by the atmospheric conditions. Mr. Dwi Cahyono explained that terahertz communication are more robust to weather effect in general, and the terahertz wave are not affected by turbulence-induced scintillation, which is observed as intensely fluctuation at the signal as much as free space office links. Mr. Dwi Cahyono also insightful share that there are some scenarios to implement terahertz communication, such as interplanetary communication by hybrid terahertz and free space optic links. Several applications, including space observation, Internet of Things, and maritime monitoring. Terahertz communication capability can also be integrated into FSO communication architecture to support high data rates. In this presentation, Mr. Dwi Cahyono also shared his interesting research result in the field of terahertz communication, including terahertz room communication and terahertz antenna array, which is very interesting presentation. And in the afternoon presentation, Mr. Christian Paturov, CEO of Pacific Broadband Satellite, who has presented the topic of HTS role in delivering broadband service in the Asia-Pacific region. He explained that Pacific has implemented an HTS satellite with the main coverage in Southeast Asia and Pacific Island. Pacific is the next generation broadband satellite operator, which is committed to providing universal, fast, high-quality broadband access at an affordable cost using robust technology and agile business model. Pacific focuses to provide reliable, fast, low-cost satellite internet at the home, business, and government across Asia and Pacific. Currently, with 56 spot beam, Pacific is serving in Ka-band HTS satellite, servicing 39 million people in 25 different countries. Pacific coverage is most ready in all of Indonesian areas, Papua New Guinea, and many other Pacific Island countries. Mr. Christian Patruk also shared the benefit of Indonesian people to using the HTS satellite technology from the perspective of time to market, quality, affordable price, and easy to access, especially in the rural area. Moreover, Pacific also provide the tailored HTS solution that will be benefit to community services, maritime, and offshore communication. Second insighted speaker in the afternoon, Mr. Sri Sanggrama Aradia, Satellite and Access Interdivision Head Bakti Kominfo, just also shared regarding digital broadband implementation via satellite communication and HTS. He shared insightful information that Bakti Kominfo is currently the mainstay of the government in accelerating the development of telecommunication network, including broadband communication, especially for underdeveloped, outmost, and frontier areas. For satellite access program, Bakti is focusing to provide internet access for school, clinics, and local government offices in rural areas. Mr. Aradia also shared that under USO programs, Bakti has built a few broadband networks, especially using LAN and C fiber optic technology, but is still developing network based on satellite telecommunication technology, as well as HTS network. To develop their network, Bakti is mainly using public-private partnership PPP project approach. Satria 1 is also government multifunction satellite that use HTS technology. The main reason that because satellite is expected to be the best solution in providing telecommunication networks in Indonesia, challenging geographical condition for terrestrial network provision. For Satria 1 project, there will be planned about 150,000 locations as a point of presence of Bakti Kominfo broadband internet HTH, which is currently under construction and will be ready in operation and maintenance in Q4 2023. Bakti also preparing the hot backup satellite project, which will have 7 earth stations located in several cities in Indonesia. The hot backup satellite project will have 2 sets of satellite control center, primarily SCC and backup SCC, with the primary SCC located in Cikarang, Bekasi, West Java, where the antenna and RF subsystem are located in Banda Aceh. The SCC backup located in Banjarmasin, with the antenna and RF subsystem located in Kupang, East Nusa Tenggara. All of those topics which we have discussed are very interesting, full of insight, and important to all of us. All this raised the obvious question of what could or should be done in addressing some of the important issues, especially in the nano satellite research area. There were a number of more specific questions raised during the discussion, which may need further examination by the committee from the ICCF and IEEE EAS as well. Throughout the day webinar event, the issue of development of what we have discussed by several speakers, they highlighted that opportunities and benefit that the nano high throughput satellite technology has already launched and continued developing to get the improvement of performance. As we may aware, although there are still many discussions about nano satellite, especially related to the potential of harmful interference, emergency communication, and mega constellation impact of nano low Earth orbit satellite, which is consisting of an environment impact, space industry impact, and space economy impact. The ITU findings indicate a possible launch of more than 1 million LEO in the next 10 years. And there are new applications for remote sensing, Earth observation, science, defense, position, and navigation. There is potential to develop LEO and GEO hybrid solution and build smaller and more efficient LEO satellite, which have less impact of the environment. Finally, my deep thanks and of course reserved to IICF, IEEE EASS for the priceless contribution and for running an insightful web seminar event, which is, I believe, very useful to the community and also to all of us. Thank you very much. And I send it back to the time to Mr. Kinan. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Mr. Satrio, for the summary and closing statement. Here we are at the end of the seminar. I believe that during this seminar, all of us has obtained a fruitful discussion. We have learned a lot from these seminar sessions delivered by the amazing speakers and moderators who made the seminar more interactive. Once again, on behalf of the committee, thank you very much for delivering such an important materials so that all of us can deepen our knowledge. Furthermore, I would like to thank all participants who have joined the seminar from all over the world. I sincerely hope that through this seminar, all of us can contribute and develop technology in our own countries. Finally, I would like to thank all of the committee members for organizing this conference and ensuring that it proceeds smoothly. I would like to apologize for any inconvenience that you might experience during the seminar. I hope we can meet again in another good chance, and thank you very much. To all participants, please fill the attendance form on the chat section.
Thank you.
Thank you very much.
Thank you very much.
Thank you.
Terima kasih Mas Kinan sudah bertugas dengan sangat luar biasa.
Terima kasih
Luar
juga.
biasa.
Terima kasih Bapak Ibu.
Tepuk tangan. Kinantar.
Terima kasih Pak Arifin, Pak Edi, Pak Satrio.
Ibu Agnes, terima kasih Pak Edi, Pak Satrio.
Ada Pak Syahrial nih.
Oh Pak Sahrial. Iya Ibu. Luar biasa.
Arifin luar biasa.
Pak Edward, terima kasih. Mas Andriones, terima kasih. Dan
Terima kasih
seluruh
banyak Pak Arifin, Bapak Edi, Bu Agnes,
luar
teman-teman
biasa.
semua.
Sami-sami.
Hari full.
Saya boleh izin live ya? Izin live.
Terima kasih ya Bu.
Selamat
Luar
malam
biasa.
Minggu. Selamat
Izin
malam
live
Minggu
juga.
ya Bapak-bapak dan Ibu-ibu
Ya.
semua.
Ya Bu, terima kasih
There
Bu.
will be HTS
Jangan-
session
jangan
next
bosan.
week from Monday to Wednesday by ICF.
Apa Pak? Apa Pak?
Yes, on Monday until Wednesday next week ada training HTS
Oh iya.
Oh,
Ya.
oh mantap.
di Jakarta.
Cakep, cakep, cakep.
Oke.
Sukses ya Pak Edi.
Sama-sama Bu.
Luar biasa Pak Edi.
Aku tunggu salamnya. Dadah.
Itu teman saya
Selamat
pengen
Pak
training
Edi.
ATS Pak.
Oke.
Ibu, Bapak, terima kasih atas waktunya. Saya mau izin keluar dulu ya Bu, Pak.
Oke, sama
Iya,
saya
iya.
juga.
Nah, terima kasih.
Terima
Pak
kasih
Edi,
Mas
Pak.
Kinan.
Terima kasih banyak Pak. Pak Edward,
Terima
terima kasih.
kasih.
Saya izin keluar. Assalamualaikum.
Waalaikumsalam. Pak Edi, terima kasih banyak sekali
Terima kasih,
lagi.
Pak Arifin. Ya, saya pamit dulu Pak ya.